Hello everybody, am I audible? Please let me know in the chat box. Hi everybody, good evening. எல்லாருமே ஹாப்பியா சேஃபா இருக்கிறீங்களா? Yes or no? Hi Galaxy. Hi Hari. So இப்பவே you can like the video, share the video, and you can also share with your friends. In 3 minutes we are going to start the session. Okay, before that we need 100 likes. Okay, and the 100 likes kadachadukku appuram da we are going to discuss the questions. Are you guys ready? Ready? Audio video la perfect dana? Done. Okay, yes, I can see few people over here. Okay, very good. Volume low. Okay, let us make it high. Okay, wow. Okay. Now can you check it? Thank you. Okay. So ippave you can just share with your friends, okay? As I mentioned, along with us, our friends also should study. Okay. Perfect. I'm waiting for more likes. I'm waiting for more hearts. I'm waiting for more fire. Then we can start the session. Yes. So I just wanted to tell you people one thing. Major are definitely, like we know that every day we are providing a lot of study materials for you people. So adanala marakkama each session you can attend, so that will give you more study materials. So and also on the study material, okay, I got the study materials. Adikapro, if you're just looking at the study material, nothing is going to happen. Okay, you should practice the problems, you should study. Otherwise na physics exam vandu koncham difficult agapora. Okay, so what we are going to do is we are going to solve the CBSE sample question paper. Okay, in the CBSE site and the sample question paper that's what we are going to do right now. So do like now, share with your friends now. Yena in the question paper vandu crucial. Okay, you will get the pattern of the exam. Okay, and it will boost your confidence as well. Okay, so majority, like we have done few chapters, almost all the chapters revision is done. So ipo the question practice the important. So inneki we are going to solve the sample question paper. Are you ready? Arambikkalama? Tell me in the chat box. All good, all said. Hi Jenny. Hi Mani, right? Yes. Priyanka, hi. Yes. Hi MS Dhoni. Galaxy, yes. Everybody is here. So as I mentioned, Marakama, like, share, subscribe. Yena vanda physics sessions vanda surprise you are going to get more lectures. அது மட்டும் இல்ல, அதுக்கப்புறம் கெமிஸ்ட்ரி classes also you are going to get it. So மறக்காம subscribe பண்ணிக்கோ. ஏன்னா இந்த சேனல் வந்து giving you high quality academic content. அதனால இப்பவே சேனல் subscribe பண்ணிக்கோ. Okay, my name is Sabri. Okay, Sabri. Okay, so let us go for the session. So I will show you the questions, and I just wanted to see the questions in the question. When I'm showing the question, and the next second I need to get the answers in the chat box. Okay, let me see who is going to give the answer first. Okay, ready? Arambikkalama? Okay na, just fire போட்டுக்கோ in the chat box la. NCERT questions also can expect. We cannot ignore. Yeah, அது வந்து syllabus. Okay. Yes. So let us go for it, guys. And adukku munadi ipo I just wanted to know one small thing. Okay, ipo we have this community right now. So idla those who are going to prepare for, or those who are going to write Neet exam, can you just give me a heart if you are writing Neet exam this year? Give me a heart in the chat box, please. Session timing na இன்னைக்கு வந்து 30 minutes late ஆச்சு. ஆனா tomorrow வந்து sharp 5 o'clock and Thursday 19th வந்து we will start at 11. அது வந்து mega marathon session தான். So everyone should attend by 11 o'clock. அதுல வந்து quick revisions இருக்கும். Okay. So yeah, I can see a lot of Neet people. Okay. Wow. These many students are writing Neet exam. Oh my god, I'm getting energy. So in the Neet sessions வந்து miss பண்ணாம you should watch. Okay. So ஏனா we need to get additional support. We need to get more practice question. அதனால இந்த சேனல்ல we will be providing a lot of things. So trust us. And also yes, I can see a lot of many students are going for Neet. Oh my god, a lot of my students are going to get this time. You are going to get Neet exam. So let us go for this session. So I'm going to show you the first question, okay? And the first question I will show you. Adukapra I need to get the answer. Yena MCQs da. First 16 questions vande MCQs da. Okay, let me go for it. Yes, here we go. If a charged hollow sphere and a solid sphere of aluminium and copper with equal radii are in electrostatic equilibrium, which of the following statements are true? Okay, it is asked for which statement is true. Okay va? So few people are saying A. Yes, Tales of Mintra, right? Yes. Super. Everybody super. Very good. So if I want in the question la, it is asked for a hollow sphere as well as a solid sphere. Okay, va? So in the question la it is mentioned electrostatic equilibrium and it is mentioned and the radius very good. And the radius same. Correct? So appadina I'm just going for the capacitance of an isolated sphere. And the value 4 pi epsilon naught r. Correct? 4 pi epsilon naught r. Appadina I can say that in the radius same da. Adinala capacitance of the first one is equal to second one. Next one is identical. So fine. So adukapro it is mentioned equilibrium. Adinala I can say the potential kuda same agapore. So adinala if I'm checking on the Q value, okay, the charge will be coming as CV. Appadina in the case C1 V1, I mean C1 is equal to C2, V1 is equal to V2. Appadina we can say that in the charge the amount of charge on the spheres equal agapore. Hence option A is the right answer. Let me show you the next second question. Are you guys ready? Now fire potuko. Yena first question la ivlo. I mean you guys said like ma'am we are tensed, we don't know anything, we can't do anything. And you are started with a you are very in an aggressive mode. Adu positive response da. Okay. Yes, very good. Perfect. So I'm going for the second question. So you can give the answer now. Second question, third question. Oh, it's there. Fine. So if I want the second question, I will tell you when you need to give the third question answer. Okay. So if I want the coil contains n turns of insulated copper wire of diameter d. Okay, so idhula n turns irukku. Okay, n turns irukku and the diameter d, resistivity rho, wound on a cylindrical, okay, wound on a cylinder of diameter d. Idha nama cylinder. Okay, idoda diameter d. Okay, idoda diameter d. What we have done now, we wound the copper wire on the, very good, oh my god, getting a lot of answers, but check again, okay, check again, wait for some time. Okay, so ipo what we have done in the diameter, in the cylinder order diameter I got a lot of answers. Just wait, we can check the answer. Okay, hold on, understand the steps. Okay, it is not about giving the answers, you should know how it comes, right? Correct. So ipo as I mentioned, the diameter of the cylinder capital D. Okay, and I'm using this copper and I'm wounding this cylinder. Adoda diameter small d. Okay, adoda diameter small d. And what is the total resistance between the two ends of the coil of copper wire? Two ends of the copper wire, and it is given that D is much greater than D. புரிஞ்சுதா? I'll read the question again. A coil contains n turns of insulated, I can't see here, okay, n turns copper wire of diameter d, resistivity rho, wound on a cylinder of diameter d. What is the total resistance between the two ends of the copper wire? இதுதான் வந்து question. இப்போ இதுல if I'm just checking on the resistance. Resistance na என்ன? Rho into L by A. So இப்போ வந்து we cannot directly go for rho is there, ஆனா வந்து L and area we should replace. Correcta? So இப்போ வந்து you should tell me what is going to be the L, the length of the coil. So அதுக்கு வந்து n turns இருக்கு. Okay, n turns இருக்கு. அப்படினா அதோட total length வந்து circumference. கரெக்டா? Circumference na என்ன? For a one coil, let's say there is only one turn. அப்படினா அந்த circumference என்ன? One turn na, what is the circumference? Tell me. Yes, very good, Srinidhi, right? 2 pi r. Only one na 2 pi r. இப்போ வந்து we have n such turns. அப்படினா total length வந்து n into 2 pi r. Correcta? Okay, 2 pi r. இப்போ வந்து I just wanted to tell you what is this 2 into r? What is 2 into r? 2 into radius, diameter. So I'm just replacing in the length வந்து nothing but n into d. Correcta? This is the diameter of the coil into pi. N pi d is the length. புரிஞ்சுதா everybody got it? இப்போ வந்து we got the length. Next வந்து we should know the area. Correcta? We should know the area. Correcta? Yes or no? So what is going to be the area? What is going to be the area? Tell me what is going to be the area. What is going to be the area? Yes, what is going to be the area? Area வந்து it will be coming as pi into d by 2 the whole square. Correcta? So இப்போ வந்து we should just substitute here rho into what is L? What we got? N into d pi. Okay, divided by, okay, we just took the wrong one. I'm sorry. Okay, sorry. Okay, so length வந்து 2 into r into pi into n, and we can say that in the 2r வந்து capital D. Correcta? Because that is what the diameter of the cylinder. Understood? So அப்படினா you just understand. Okay, we have taken the wrong one. Understand? இப்போ வந்து we should find the length. What we are doing? We are taking the copper wire and we are wound correctly like this. Correcta? So இப்போ வந்து the length வந்து it will be about the cylinder. புரிஞ்சுதா? We have just took the opposite one. Understand? இதுதான் வந்து cylinder ஓட radius. புரிஞ்சுதா? So இப்போ வந்து this is how we are just keeping the copper wire. அப்போ the total length வந்து it is going to be 2 into pi r for one turn. அப்படி we have n turns, so you will be getting d into pi n. இப்போ வந்து area of cross section வந்து the material and the copper ஓட area of cross section தான் we need it. Correcta? We need the area of cross section of the copper. அப்படினா we can say pi into d by 2 the whole square, pi r square. Correcta? இப்போ வந்து we can just substitute rho is equal to L by A. So rho into L na என்ன? N pi d divided by pi d square into 4. So இப்போ வந்து pi will be get cancelled and we will be getting 4 rho n d by d square. Hence option A. Understood? If you guys understood, please give me a thumbs up in the chat box. Any confusion on the on the diameter, it is very important when we are taking the area of cross section of the copper wire. We are finding the resistance of the copper wire. Next the length of the copper wire. The length of the copper wire, when we are finding, what will happen? What will happen? Yes, we will be wound like this. So one turn now, it will be nothing but 2 pi into radius of the cylinder. Okay, n turns irukku, so we will be get it like this. Purinjada? Everybody, yes or no? Yes or no? Let us go for the third question. Let us go for the third question. Can you give me the answer now? First, you should tell me this is representing which device? Which device it is? I understood. A. Jenny, very simple. So, now I have this cylinder. Okay. In the cylinder diameter D. Correct? Now, what I'm going to do? I'm going to wound it with the copper wire. So, this is the first turn. Okay. Let us say I'm just going for only one turn. Appadina, the length what is going to be the length? What is going to be the length? This is what the first turn. Idhula in the diameter D da. Appadina, in the one turn will give me 2 into pi into, here I will be having D by 2. Correct? 2 pi R. Okay, va? So in the madri I have n turns. So total length it will be coming like this. Purinjada everybody? Understood? So now the length we got n pi into D. Next the area. Area now for which material I'm taking? For the copper wire. So on the copper wire diameter it is given as D. Appadina area of that one is coming as D by 2 whole square. Then we will be substituting in the yes. Okay, so now you can go for the third question. So current is lagging. Correct? Current is lagging. So what is going to be the answer? Current is lagging by 90 degree. Yesterday only we have studied this. So now you can just check on it. In the frequency increase, sorry, 1 second. Okay, give me a second, guys. Give me a second. I'll just come, okay? It's not in mute. This opposite one, that monitor. Because a lot of messages are coming and it is making some noise. Yeah. No, I'm in a session. Yeah. Yeah. sorry guys. So let us continue. Okay, yeah.
Click on that text icon.
This one.
Muted. Click on it.
So now we are going for the third question. In third question, there is a phasor diagram. So right now the thing is like this is coming as a frequency. Huh?
Ask them it is fine. If it is fine. Only because of this is what coming.
So right now the thing is like we have the yes, what happened? Yeah. So we have the circuit diagram here. இப்போ வந்து we should know when frequency increases. இது வந்து capacitive circuit. So definitely what will happen? We know that XC will be coming as 2 pi f omega c, right? So இப்போ வந்து we know when frequency increases, this will decrease. When frequency decreases, XC will increase. அப்படினா definitely what will happen? In the impedance வந்து it is going to reduce. புரிஞ்சுதா? Everybody understood? Yes or no? Okay. So now we can just go for அப்படினா when the frequency of AC sources increase, then the impedance of the device decreases. Okay, option A is going to be the right answer. இப்போ வந்து we are going for the next question. Which of the following statement is true for the radio waves and gamma rays? You can give me the answer now. You can give me the answer now. What is going to be the answer? What is going to be the answer? Which of the following statement is true for the radio waves and the gamma rays? What is the answer? Yes, very good, very good. Option D, the energy of the radio waves is lesser than that of the gamma rays. So it is a direct question, so you can just directly go for it. Next one, a glass prism is has an internal angle 45 degree and 45 90. Yeah, three angles are 45 45 and 90 degree. The glass has a critical angle of 45 degree. Which of the following ray diagram depicts the possible path of the light through the prism? Okay, okay, wow. Okay, so right now the thing is like we know the critical angle is given as 45 degree and a glass prism has internal angles of 45 45 90 degree. Okay, wow. Okay, so now you should go for the diagram. Can you go for it? So try to complete the diagram first. Try to complete the diagram. Check again. Okay, so now I'm just going to do one thing. I can just see that what is going to be the refractive index. First we can go for the refractive index. Yeah, na? We know the refractive index mu, or let's say n, is having a relation with the critical angle, correct? So that is nothing but 1 by sine theta c. So appadina I can say that this will be nothing but 1 by sine 45, which will be equal to 1 by 1 root 2, correct? Yes or no? Yes or no? Okay, so now you will be getting the refractive index. Okay, we got the refractive index as root 2, n, the refractive index the root 2. Okay, so next one we should know the refracted angle. So we are just going for first you can just see that in the first diagram it is proportional to, in the incident ray proportional to the base. So I'm going for it. So now you can see the incident ray is falling like this. So first of all, to know the incident angle, we should go for a normal. So I'm drawing a normal also. Okay, wow, we got the normal as well. So now after refraction, we know that the refractive index is more than the rarer medium, or let's say this is the rarer medium and this is going to be the denser medium. Now we can say that it will bend towards the normal, correct? Rarer to denser, what will happen? It will bend towards the normal. Okay, wow, got it, everybody? Everybody got it? So, we have seen that after refraction, I'm just going for the normal over here. Okay, I'm going for the normal over here. So, you can see that the normal is here. Okay, so we should know few angles. I know this angle is coming as 45. Yeah, now it is already given in the question that the angles which is coming as 45 and 90 degree, correct? So appadina I can just go for this angle is 45, this angle is also going to be 45. Okay, and we should know ipo idu vandu 45 na, I can say this angle is going to be 90 degree. Ena adu vandu normal, and the surface oda normal. Purinjida? Everybody understood? So that is coming as the normal. Okay, so what we got the refractive index of the medium. Let it be there. Now I'm just going with the first diagram. So on the diagram, in the incident ray actually parallel to this one. So I'm just going for this incident ray, and I will be getting this angle as 45 degree. Yeah, na, these are two parallel lines. So I can say this will be 45 degree. And already in the question, it is given the angles are 90 degree and 45 each for the rest of the angles. So we can say that in the 45 degree and here we have the 45 degree, inga vanda 90 degree. So we can say this also coming as the 45 degree. Okay, va? Understood? Everybody understood? So, we can just go for sin I is there. So, we got the refractive index also. You are not getting it? Confusing? Okay. So, first one, we have the surface, right? And the surface, we have draw a normal. Correct? So, upon the normal one, it is making an angle 45 degree. Purinjida? Everybody got it? And the normal one, it is making an angle 45 degree. Till that is understood? Till that is understood, everybody? Yes or no? Yes or no? Okay. Answer one the option A da. Answer one the option A. Okay. Answer is option A. That is why I'm just focusing on that diagram. Okay. Yes. So, we understood this angle is 45. This angle is 45. And we know the refractive index also. So, we can find the refracted angle. Yena sin I divided by sin R, which is equal to, we can say that is root 2. Can you find sin R right now? Can you find sin R right now? Can you find sin R now? Can you find the... No? Check, hold on. Okay, so the sin R will be coming as sin I 45 divided by root 2 will be sin R. So, sin 45 na 1 by root 2 divided by root 2 will be giving you 1 by 2. That is what sin R. So, R will be coming as 30 degree. So, we can just say that in the refracted angle 30 degree. Okay, refracted angle 30 degree. Purinjida? Refracted angle 30 degree. So, now you guys have to focus on one triangle. Here we have the refracted ray. Here we have the the two sides of the triangle. So in the triangle, already we know this is 45 and this is coming as 90 degree. Now you got this is 30 degree. So அப்படினா the total angle in a triangle வந்து 180 degree. So அப்படினா we can say 45 இருக்கு, 90 degree plus 30 plus this angle, okay, plus this angle, correct? Plus this angle. So we can say that, let me just write it as theta. So அப்படினா can you find theta for me now? Can you find theta for me right now? Okay, so இது வந்து சிம்பிளான question தான். Just you need to complete the ray diagram. First you will be going for the normal. Okay, so first வந்து we will be going for the normal. அப்ப வந்து we understood this is a parallel line. So அப்ப வந்து this angle also going to be 45 degree. So அப்படினா I can say that after refraction and the refracted angle வந்து √ 1/2. So அதுக்காக 30 degree 1/2 வருது, it is for 30 degree. So அப்படினா I will be getting this angle also because I'm considering the triangle which I have given in the yellow color. அதுல வந்து this is making with the normal 90 degree, refracted angle we got 30 degree, இது வந்து 45 degree. புரிஞ்சுதா? 45 degree. So அப்படினா this angle will be coming as 15 degree. Okay, so 45 degree irukku, 30 degree irukku, 90 degree irukku. So the rest will be coming as 15 degree. So now in the point illa I'm going for a normal again. Okay, in the point illa I'm going for a normal again. அப்படினா I can go for, if this angle is 15, what is going to be this angle, guys? Can you tell me the answer? What is going to be the incident angle on this surface BC? What is the incident and the refracted ray வந்து it will be falling on BC. அப்படினா இந்த BC it will hit on BC. அதுக்கப்புறம் what will happen, guys? What will happen? It will hit on BC. So அதுக்கு incident angle வேணும், that is coming as 75 degree. Okay va? So in the BC surface ila and the light வந்து making an incident angle 75 degree. Now coming back to the question, a glass prism is internal angle of 45 90 degree. The glass has a critical angle 45. Which path is going to be, or which diagram is correct? So ipo வந்து we know that when this internal reflection will happen, when the internal reflection or total internal reflection will happen, when the light is traveling from a denser to rarer medium, when the incident angle is more than the critical angle. So inga vandu critical angle 45 and we got this incident angle is 75, which means it is more than the critical angle. Appadina what we can say? Yes, perfect, Srinidhi. So we can just say that this will be go for total internal reflection. Okay, so அப்படினா option A da correct. So adanaala you don't need to even go for the rest of the thing. Even for the rest of the things you should do the same process, but we got this answer. So adanaala we can just go for the next one. Okay, light passes from a certain medium into air. The critical angle of the given medium is theta. Which of the following expressions give the speed of light in the given medium, where c is the speed of the light? So this is a very simple question. You can give me the answer in a second. Can you give me the answer? Give me the answer quickly, everybody. Very easy question. Light passes from a certain medium into air. Critical angle of the given medium is theta. Which of the following expressions gives the speed of light? So we should know few relation. In the refractive index வந்து 1 by sin theta z and the refractive index oda relation na c by v. Think and tell me the answer. Hari, check again. We need to know few relations. Refractive index order relation na, it is nothing but c by the velocity in the medium. So here I'm taking it as v. Next one, the refractive index we know 1 by sin theta c. 1 by sin theta c. So now you can just go for the relation. Very good, very good, very good. It is going to be option D. Very good, very good. Perfect. You guys are done something, guys. I'm telling you. Otherwise, you won't be getting the answer, right? So, we know n is equal to 1 by sine theta and n is equal to c by v. Okay, and we need to know the velocity of the medium. So appadina velocity of the medium, I can go for c by n. So c by 1 by sine theta will be coming on the top. So I'll be getting c sine theta. Purinjida? Yes or no? Yes or no? Let us go for the next question. Okay, va? Okay, marakama like panniko, share panniko, subscribe. You need to subscribe. Yeah, na, as I mentioned, we are going to give a lots of contents for you people. So marakama subscribe panniko. Telegram link vandu channel la description box il irukku. So adula vandu you can join. So you will be getting more updates and whatever be the schedules, everything you will be getting in the Telegram channel. Okay, va? So let us go for the next one. So ipo vandu the light. Okay, the light from a monochromatic source is incident on a option D, question mark. Okay, so it is incident on a, I can't read actually, incident on a single slit and resulting diffraction pattern is viewed as the screen. This is what is the diffraction pattern we got. The graph shows the variation of the intensity with the distance of the screen. Okay, so intensity of the screen. Yes, good evening, Damodara. Yes, everybody is getting. So yesterday we have studied few relation, right? Few relation. A sin theta, adada vandu path difference, correct? So A sin theta, which is equal to for maximum intensity, we have mentioned it is n lambda. So appadina we can say A theta which is equal to n lambda. Okay, so now you can just work on it. Yes, Darshu, perfect. Yesterday only we have studied all these conditions, everything. Very good. So now you can go for it. Yes. Very good. So the graph shows the variation of the intensity with the distance of the screen. If the width of the slit, which means we are increasing the A value. Okay, A value. If you are increasing the A value, okay, for the same condition, which of the following graph? If the A value increases, what will happen, guys? What will happen? Definitely in the width vandu reduce agapore. Okay, va? In the width vandu reduce agum. In the theta will be proportional to lambda by A. So adanale when A increases, theta is going to reduce. So which means we can just say that this will become narrow. So the answer will be option D. Very good. Perfect. The phenomenon of superposition of two waves resulting in redistribution of the energy is known as and the slit width. So now tell me answer for this one. Everybody knows it. Yes, very good, Galaxy. Very good. It is nothing but interference. I'm skipping this question for now because it is an easy one. Now, which of the following transitions correspond to emission of radiation of maximum wavelength? Okay, emission, it is asked for the emission. So, emission we can just say that when it is going from lower energy level to the higher energy level, it will absorb. So, adanala we can remove few things. This 4, 6, 3, everything will gone, and the rest is coming from a higher energy to the lower energy. So appadina it will emit some energy and it will be coming to the lower energy. So definitely we can just go for option C is the answer. Option C is going to be the answer, which means this is the one will be having the maximum wavelength. So ipo vandu similar on a question, which of the following transition correspond to the emission of radiation of the maximum wavelength? Same, similar type question from atom. So can you give me the answer? Same type question. Very good, very good, very good, very good. Yes, you people are becoming more specific. Specific answer 4C. So definitely the answer one, the same concept tha. We know the 1 by lambda equation, so that will be proportional to 1 by n1 square minus 1 by n2 square. So you can go for it, and we will be getting the answer as from third orbit to second orbit. If you are substituting the value for the rest of the cases, this is going to be the least one. So wavelength will be the maximum. Very good, very good, very good. Let us go for the next one. A charged particle is projected along the axis of a current carrying loop. Which of the following statement is true? Which of these following statement is true? So understand, we have a charge, we are projected to the to the axis of a current carrying loop. Think. We have discussed day before yesterday, we have discussed about the charge is projected to a different scenarios, parallel, anti-parallel, perpendicular, making with an angle theta. Just try to connect with the current loop. So what is going to be then the current loop the only thing which you should know is what is going to be the direction of magnetic field. Adu mattum podum, then relate with whatever we have studied. You will get the answer. Very good, guys. Very good, very good. What is the answer? Very good. Very good. Perfect. Yes, option D is the right answer. Yeah. Because we know that in the current carrying loop, current is going like this. Appadina, in the magnetic field order direction, it is along the axis. Appadina, the projected charge, it is moving along the axis. Appadina, in the question they have given. Appadina, we can say that it is parallel or anti-parallel. Appadina, there is no magnetic force. If there is no magnetic force, it will move in a straight line with a constant velocity. So, appadina, we can say option D is the answer. Purinjida? Got it? Yes or no? Let us go for the next one. Okay. So, we have two small identical magnets are allowed to fall freely, one through a vertical solenoid of 20 meter made up of copper, another in air through the same vertical distance, the time taken by the two magnets. Definitely you can use your logic and give me the answer quickly. Think and tell me the answer. Very easy question, very easy question. Very easy question. Which one will be taking, the time taken by the two magnets to fall? Is it going to be same? No way. Okay, all the options are C, right? Why so? Okay, more for the magnet falling in air, more for the magnet falling through the solenoid. So definitely we know that option C is going to be the answer. Why? What is the reason, guys? What is the reason? Tell me the reason. Yeah, we know that whenever this magnet is falling through the solenoid, definitely there will be a flux change. Adanala, there will be an induced EMF, and the induced EMF will try to oppose the motion. Adanala, there will be a magnetic force upward. And in the freely falling body, in the air larikra body ke, and the force kedaiyadhu, so it will move with an acceleration, that is G. And in the case there will be a magnetic force. Okay, there will be a magnetic force which will be in the opposite direction of motion. Adanala, the second one, or let's say which one is moving through the solenoid, will take more time to cover the distance. Okay. So, we are going for the next one. The EMF generated by AC generated is given by V is equal to V0 sin omega t, where omega is the angular frequency of armature generator. What will be the EMF if the angular frequency is doubled? What is going to be the EMF if the angular frequency is doubled? Think and tell me. Think and tell me. Yes. We know what is going to be the peak voltage value. So first வந்து இப்போ இந்த angular velocity double ஆச்சுனா what is going to be the peak voltage, which means what is going to be the change which is happening with the V0. அதுதான் first we should know. So you can just go for that first. We can go for that first. What is going to be the maximum voltage value? V0, which is equal to NAB omega. இப்போ வந்து what happened? V0 dash வந்து NAB 2 omega. அப்படினா I can say V0 dash will be coming as 2 NAB omega. Right? So this will be coming as 2 V0. இப்போ வந்து we should know the angular velocity. Again we are going to change. So V will be coming as 2 V0. This one in the peak voltage, and sign instead of omega you should go for 2. So the answer the option C. புரிஞ்சுதா? Let us go for the next one. Are you guys ready? ரொம்ப ஈஸியான question. You should give me the answer quickly. You should give me the answer. Give me the answer. Yes. Very good. Perfect. So in the nuclear density it is not depending upon the mass number. So the ratio will be coming as 1:1. Okay. Perfect. So next question when we move magnetic compass from point P to Q, then which of the following statement is true? Can you just check with the statements? You can check with the statements. There is a point P as well as Q. Okay. So we need to know what will happen at P as well as Q. What is happening at P? What is happening at Q? I hope it is, you can read it. Okay. Not getting much answers. Think. So when it comes to a solenoid, we know that at the ends the magnetic field becomes half of it. Okay. And when it comes to this area, it is almost weak. Okay. We cannot expect the same magnetic field as such at the ends or in the axial line. So when it comes to this point, it will become weak, and it is almost like opposite in direction. So appadina we can say the deflection of the magnetic needle at P and Q be in the opposite directions. Okay va? Be in the opposite directions. Next one we have a question, numerical we are going to solve it. The amplitude of the magnetic field of a plane electromagnetic wave, okay, propagating along the positive x-axis in vacuum, it is nothing but 510, right? Okay, and the direction is also given k cap, and its angular frequency is given 60 into 10 to the power 6 radian per second. Write the expression for electric field. So for that we should know few things. Okay, we should know few things. First of all, you should know how to write a wave equation, right? How to write a wave equation? We can say, let us say y is equal to a sine omega t minus kx. Then when it comes to, it is given, we need to find the electric field, and it is given for the magnetic field. So on the magnetic field and electric field, the peak value find pandradhukku we know one equation. What is that? E0 is equal to, or E0 by B0, which is equal to C. So appadina you can just substitute it. You can find, very good. So you can just substitute it and you can find the equation. Okay va? Okay everybody? Yes or no? So substitute. First you have to find the E0 value. Okay, omega is given, correct? Omega is given. Then you can go for the equation. We need an expression. And also the direction also it is required, because it is mentioned E vector. So whenever you are finding the expression, adanalada we are saying we should always read the question properly. Idhula the vector, the direction also required. And how we will be finding K? How we will be finding K? How we will be finding K? It is nothing but omega by C. E naught will be CB naught. So you can find these values and you can substitute and you can make a relation. Yes, very good, Galaxy. Substitute and find it. So E naught will be coming as 3 into 10 to the power 8 into, what is the value? 510, right? 510 into 10 to the power minus 9. So after doing this, what you will be getting? What you will be getting? You will be getting 153 as E naught. Okay, volt per meter or whatever it may be. So 153 is going to be the peak value. If you should find K value. K value na 60 into 10 to the power 6 divided by 3 into 10 to the power 8. So now you can just get the K value as well. Okay. 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 So we are writing electric field is equal to 153. Okay. Sine 60 into 10 to the power 6 omega minus, this will be coming as 0.2, right? Into, yeah, that's it. Okay. So that will be X. And now it is the turn for the direction. For the direction, it is mentioned the magnetic field direction is given. So you should know E cross B will be giving you the direction of propagation. Okay. E cross B will be giving you the direction of propagation. Direction of propagation. Okay. So E cross B, which is equal to propagation. So we know that B, magnetic field order direction one the J cap. Correct? It is given in the question. Okay, wow. And it is mentioned the wave is propagating in the positive X direction. So appadina we should go for the equation in the direction of E vector cross J cap, which is giving I cap. So appadina, what is going to be E cap? You should tell me what is going to be E cap. What is going to be E cap? Very good, very good, very good. See na 3 into 10 to the power 8, the speed of light in vacuum. Okay. Okay. So I made a mistake maybe. Yeah. Okay. So what is going to be the direction? E cross J will be coming as, E cross K. The direction of B is K cap. So we will be getting minus J cap as the direction of E. Purinjida, everybody? Everybody understood? Yes or no? Yes or no? How it will be? This will be 0.2 only, right? 0.2 only. Okay, so now let us go for the next question. So Ipavanda, we should find the following graph shows the potential difference across the terminal of a cell against its load current. Okay. Okay. So now you should find what the EMF of the cell and the internal resistance of the cell. So we have one equation we have studied in the current electricity. What is the equation for EMF? Everybody tell me what is going to be the equation for EMF. You can tell me the answer in the chat box, everybody. Everybody tell me. EMF for equation anna? EMF for equation. E minus IR, which is equal to V. Okay, va? Purinjida. So if we can find the values here. Yes, very good, Jenny. Very good, very good. Now we have the potential as 6, and during that time the load current, right? During that time the load current is 0. So அப்படினா you can find the EMF when current is not flowing through the circuit. What is the potential terminal potential difference? அதுதான் வந்து நம்ம EMF. அதனால I can say this will be coming as EMF வந்து potential 6 தான், ஆனா current வந்து 0. So we will be getting what? We will be getting EMF is equal to 6. Now we got the EMF value. Okay, next question is we need to find the internal resistance. Okay, we need to find the internal resistance. Can you find it? Can you find the value? Can you find the value? How to find it? How to find it? It is nothing but the negative slope of VI graph. The internal resistance is nothing but the negative slope of the VI graph. So those who came right now, like the video, share with your friends, and also subscribe the channel. Okay va? Okay va? Okay, so we got the negative slope or slope of the VI graph. So what is the slope? What is the slope? Slope is nothing but delta y by delta x. So அப்படினா we can say that 6 minus 0 divided by 0 minus 12. So அப்படினா we will be getting 0.5, right? Okay, so that will be negative, and negative of that slope is known as the internal resistance. So we will be getting the internal resistance as R is equal to 0.5. It's not audible. Okay, now is it audible? Perfect. Can you just let me know in the chat box? Sound is okay for you now? Yes, perfect. Okay va? So இப்போ வந்து we understood the EMF equation. EMF equation is nothing but we have mentioned in the EMF வந்து distribute ஆகிறது for two purpose. One is for the internal, what is it, the potential difference, or let's say the potential drop which is happening through the internal resistance. Next வந்து external, whatever we have connected on the resistance. So அப்படினா we can say that in the EMF will be which is equal to V plus IR. So in the case we are taking when the current is 0, the potential value வந்து 6, so EMF வந்து 6. Okay, next வந்து internal resistance. Internal resistance na very simple, it is nothing but the negative slope of the VI graph. So அப்படினா we will be getting 0.5. So இப்போ வந்து we have a charge Q is placed inside a sphere of radius A. Okay, filled with water, and another charge 2Q is placed inside the cube of side 2A, which is vacuum inside. Find the ratio of flux linked with the sphere to that linked with the cube. So we need to find the ratios of the flux. So அப்படினா you guys have to tell me what is going to be the flux in the first case. A charge Q is placed inside a sphere of radius A. Okay, what is going to be the flux? Charge is Q. It is filled with water. Permittivity of water is given. CBSE sample question paper. So those who are coming here, don't forget to like, share with your friends, as well as subscribe the channel. Join the Telegram group. And also, if you are just preparing for the Neet exam, okay, if you are preparing for the Neet exam, there we have providing the PYQs, 38 years PYQ book. So if you wanted to check it out, you can just check on the description box, and the description box il link irukku. So if you want it, you can purchase it. That will definitely boost your preparation, like how you will be getting the patterns and you will become more confident. Okay va? Purinjida? Okay? Okay? So இப்போ வந்து in the first case what is the flux, guys? What is the flux? It is kept in a medium. So we know that flux வந்து Q divided by the charge inside the Gaussian surface divided by the permittivity. Okay va? So permittivity na we can say that epsilon R epsilon naught. So here the permittivity of water is given. So I can just simply go for permittivity of the medium. So அப்படினா I can just go for Q divided by 80. Okay, va? Q divided by 80. Okay, thank you so much, guys. So, now we got the flux for the first case. Next, in the second case, what is going to be phi 2? What is going to be phi 2? Phi 2. What about phi 2? It is kept in a 2A. The cube order side one the 2A, and that is in air, and the charge is 2Q. So, appadina, what is the flux? Can you just give me the answer in the chat box, everybody? What is going to be the flux? What is going to be the flux? Tell me in the chat box, everybody. What is going to be the flux? Simple. Because Gaussian surface order area, it doesn't matter here, right? So we can just say that this will be simply Q divided by epsilon naught, and the charge one it is 2Q. So adanal I'm just telling you 2Q by epsilon naught. Ipo vanda you can go for phi 1 divided by phi 2. Can you find this? Can you find this? It is not going to be same, because the charge one, the charge enclosed is 2Q, and the permittivity one what is a epsilon naught only. Okay, because it is mentioned vacuumed inside. So appadina permittivity one epsilon naught. So now you can find the ratio. Purinjida? Understood why we are not taking the 80 value? Yena clear it is mentioned. Clear it is mentioned. Yes, perfect. So ipo vanta Q divided by epsilon naught, 80 epsilon naught divided by 2Q divided by epsilon naught. So ipo vanta we can just say that here idu vanda relative permittivity. Sorry, this is relative permittivity. So epsilon naught irukum. So epsilon naught will go. So finally Q will also go. After that, what we will be having? So check, guys, here it is mentioned relative permittivity. So appadina here only we are putting 80. Okay, so appadina we will be getting 1 by 60. Purinjida? Simple only, just we are taking the charge divided by permittivity of the medium. So in idhula vanda permittivity, relative permittivity da given. So I can just go for Q divided by relative permittivity 80 and epsilon naught. Okay, so let us go for the next one. Are you guys ready? Write an expression for the magnetic force per unit length between two parallel thin current carrying wires, hence define 1 ampere. Can you tell me what is going to be the force per unit length? Because we have studied, we have a conductor over here, we have another conductor over here, it is separated by a distance d. Appadina, and the force divided by L will be coming as, what is the value? What is the value? We have derived it, right? Mu 0 I1 I2 divided by 2 pi d. Correcta? Yes or no? Yes or no? So idudha vanda nama force oda value I1 I2 mu 0 I1 I2 divided by very good. Okay, divided by 2 pi d the and the force. Yen and the force oda expression enna? Ipa vanda if I'm just talking about the force, this is the first conductor, idu vanda second conductor. Let us do it. Okay, so ipa vanda first and second conductor we got it. Appadina we can say that due to the magnetic field, the force experienced by the second one, correcta. Okay, so ipa vanda we can just say that and the force vanda current which is passing through the if I'm just going for F12, current passing through the first one into B2 into L, and now the magnetic field in the second conductor order magnetic field we are using. So appadina we can just go for I1 L, and what is B2? The magnetic field due to a current carrying conductor. What is that? Tell me in the chat box. It is nothing but mu 0 I2 divided by 2 pi d. Ipo vanda we are taking this length here. So we will be getting mu 0 I1 I2 divided by 2 pi d. So if you are writing this question now, you should do one thing. You should write this expression as well as you should tell what is I1, what is I2, what is d, and what is the value of mu naught divided by 2 pi. Mu naught by 2 pi na enna, it is nothing but 2 into 10 to the power minus 7. So ipo vandu I can just tell you if we are going for, okay, if we are going for defining what is 1 ampere, let us say we have two conductors, okay, we have two conductors, and the two conductors vandu separated by unit distance, because in the question la vandu we have to define 1 ampere on the basis of this equation. So appadina I can just say that we have two parallel conductors, adu vandu the separated distance vandu 1 unit length, okay, and the separation vandu 1 unit length. So and the time la in the d vandu what is going to be the value of d? What is going to be the value of d? And the d value vandu nothing but 1. That is what the thing, okay va. So appadina we can say that we have mentioned f12 per length, unit length vandu mu 0 I1 I2 divided by 2 pi d. Ipo vandu we understood in the d value vandu 1 da. Appadina in the force per unit length oda value 2 into 10 to the power minus 7. Okay, 2 into 10 to the power minus 7 da and the value, and the force per unit length oda value. And the time la irukra current da in the 1 ampere. Purinchida? So just based on this equation, you can tell d will be 1. And the time la force vandu 2, or let's say d vandu 1, force vandu 2 into 10 to the power minus 7. So and the time la irukra value da and the current oda value 1 ampere. Okay. So ipo vandu we have one more question. Draw the diagram representing the behavior of magnetic field lines of diamagnetic and paramagnetic. So diamagnetic is here, and next one is right? Yes, paramagnetic. Okay, paramagnetic. So in the case of what will happen? Let us say idu da namma diamagnetic material. So idula vandu we know that in the diamagnetic materials ku vandu I mean repulsion da, I mean it likes more repulsion, correct? Okay, so yes, perfect. So appadina we can say this will be like this. Okay, so in the field lines vandu ippadi irukum, and in the paramagnet la vandu it will attract. Okay, so we can just say that in the time la it will just come like this. Okay va? So this is how the field lines you should mark. Okay. So next one. State Gauss's law of magnetism, hence find the magnetic flux linked with the sphere enclosing a current carrying solenoid. Can you tell me what is this? What is this Gauss's law? It is nothing but closed integral B dot ds, which is equal to 0. Yena monopoles in the magnet la monopoles doesn't exist. So in the field lines when the starting from one point and it will ends to the same, or let's say we can say that in the magnetic field lines when the it will form closed loops. Very good. Okay, it will form the closed loops. Appadina definitely the flux lines which is leaving the surface and entering into the surface will be same. So appadina there is no flux, it will be coming as 0. Closed integral B dot ds. Idu vandu magnetism. Adanala da we are writing closed integral B dot ds, which is equal to 0. Ipa vandu what is the next thing? We have a sphere. Adukulla we kept a solenoid. What is going to be the magnetic field? Can you give me the answer in the chat box? What will be the magnetic field? Tell me in the chat box. What is going to be the magnetic field? What is going to be the magnetic field? In this case, magnetic flux linked with it. Again, this will be in the solenoid also, it's act like a equivalent bar magnet, right? அப்படினா அதுக்கு ஒரு south pole இருக்கு, அதுக்கு ஒரு north pole இருக்கு. So in the field lines வந்து again will make a closed loop. So அப்படினா whenever we are considering a Gaussian surface, அதுக்குள்ள இந்த net flux வந்து, or let's say the flux lines leaving the surface and entering the junction entering the surface வந்து same ஆக போற. So it will be again 0. Very good, very good. How does the impact parameter affect the trajectory of alpha particles scattered by a heavy nucleus? What is the value of impact parameter for head-on collision of an alpha particle with the nucleus? So first, in the madri, if you are getting a question, first you should write what is this impact parameter. So let us say inga vanda we have a nucleus, right? Okay, so இதுதா வந்து இந்த straight line. Okay, so இப்போ வந்து the alpha particle is straight இப்படி வந்துருச்சுனா we will call it as head-on collision. So இப்போ வந்து இந்த alpha particle is coming like this and it will be going like this, whatever it may be. So இதுதா இந்த initial velocity ஓட direction, initial velocity ஓட direction. So இந்த perpendicular distance da. Okay, இந்த perpendicular, which one for the previous question? Jaswin, which question? Previous question or for this question? Which question you are asking? Previous question in the equation is necessary. Lena, how to explain, because that is what is asked, correct? Okay, so இப்போ வந்து இந்த impact parameter na, it is nothing but the perpendicular distance between these two lines da in the impact parameter. And as I mentioned, head-on collision na, in the alpha particle should go through this line which is passing through the center. So அப்படினா அந்த impact parameter வந்து 0 ஆக போறேன். Okay va? Yes, perpendicular distance between initial vector and the center of the nucleus. Okay, perfect. So அப்படினா இந்த b value வந்து it is going to be 0. Okay, it is going to be 0. So when it is a head-on collision, புரிஞ்சுதா? When it is a head-on collision, இந்த value வந்து 0 ஆக போறேன். Okay, let us go for the next one. And those who have joined new, மறக்காம like பண்ணிக்கோ. Okay va? So இப்போ வந்து we have to focus for 200 likes. Okay, எனக்கு வந்து 200 likes வேணும். Okay, so அப்படினா in the next classல வந்து we will be doing more questions. Okay, இன்னைக்கு வந்து sample question paper தான், ஆனா வந்து next classல to do more questions, இதை விட more questions if you need to do, then I need 200 likes in just 10 minutes. Okay, let's see will happen or what. Okay, perfect. So இப்போ வந்து we are going for the next question. Plot a graph variation of de Broglie wavelength lambda versus V accelerating potential for a particle of mass m and charge q. Obtain the slope of the graph. Okay va? So just listen what we need to do. We need to go for a graph which is having a variation of lambda versus 1 by root v. So now I'm just checking. We know that in the lambda vanda h by p. Okay, yesterday we have discussed this thing, correct? So idu vanda h by mv, or else we can say idu vanda h by root me, or else we can say h by root of 2mqv. So ipo vanda I can say that in the lambda vanda proportional to 1 by root v. Correcta? So ipo vanda I just wanted to know if I am plotting lambda versus 1 by root v. So how will be the graph? Can you just tell me how will be the graph? Yes, Gopinath, very good, super. Very good. So in the graph you can just compare with the straight line equation. If you are just checking on it, we can just say in the y vanda mx plus c. Okay, C வந்து 0, Z வந்து 0 na, it should start from 0. And I'm just writing Y la வந்து lambda, M na என்ன, H divided by root of 2mq. இது வந்து constant value da. Okay, X வந்து 1 by root V. இது வந்து representing a straight line, a linear graph da it is representing. So அப்படினா I can say that and the slope வந்து இந்த m ஓட placeல என்ன இருக்கு, h divided by root of 2mq. புரிஞ்சுதா? Yes or no? Please let me know in the chat box everybody. So this is how the graph of lambda versus 1 by root V. இப்போ வந்து I'm just going to ask you one more question. You should draw lambda versus root V. Can you go for the graph? This one, lambda versus root V. Board students. This is only for board students. Okay, Neet we can do something special on some other day. Okay, so இப்போ வந்து we are focusing on physics, we are focusing on the CBSE board exam. அதுக்கப்புறம் from Saturday onwards we will be going for Neet classes, don't worry. How linear na, as I mentioned, no, இது வந்து representing a equation for the straight line. அதுல வந்து constant இருக்கிறது h by root 2 mq, அது வந்து constant. Okay, so இப்போ வந்து if you are just going for lambda versus root v graph now, what will happen? It will be like this. Lambda, this is root v, so in the graph வந்து இப்படி இருக்கும். Okay, lambda is proportional to 1 by v, so sorry, root v, so we can just go for the graph like this. Let us go for the next question. Perfect. With the help of a circuit diagram, working of full wave rectifier. So we have already discussed about that. So adula vanda we will be having a step down transformer. Okay va, adula vanda we will be having 2 diodes and we are using center tapped transformer da. Yena we need a flip, correct, 180 degree shift veno. அதுக்காகதா we have the circuit diagram like this. In the diodes, 2 diodes irukku, center tapped transformer that we are using in this process, and here from the third connection we will go for the external resistance, and that is where we will be connecting the devices. Okay, connecting the devices. Full wave rectifier da, full wave rectifier. Okay, idu vandu full wave rectifier. So what is the efficiency? Full wave rectifier. Gopinath, this is full wave rectifier. Okay, so இப்போ வந்து if you are just checking on it, in the first half la positive half cycle. Okay, in the first la positive half cycle da. So அந்த time la this is how the graph which is coming in this terminal, and this is how the graph, because using a center tapped transformer we are just changing the phase by 180 degree. Okay, we are changing the phase by 180 degree. So in the first positive half la in the diode D1 வந்து forward biasing la irukum. So adula means on the first diode la irundha in the current வந்து it will passes through the current 81.2. correct. Okay, so 81.2 da in the efficiency of this full wave rectifier. Okay, so இப்போ வந்து அந்த same time la if you are just checking on D2, இதுல வந்து negative half cycle, so we can say அது வந்து reverse bias ல da, so அதனால current is not going to pass us through the second one. Again coming to the second negative half cycle, அந்த டைம்ல இது வந்து reverse, and that time this is going to be in forward. And இப்போ I'm just going for the input graph. Okay, இதுதான் வந்து input graph. ஆனா output வந்து we will be getting like this. AC ripples இருக்கும். To remove that we can use a capacitor. Okay, understood. Efficiency of half wave rectifier வந்து 40.2. 40.6 I guess. Okay. So next question வந்து the current wire is getting divided into two wires with the currents I1. So in the current I irundirichu, adu vandu I1 current irundirichu, it is splitted into I2 and I3. Okay va? So appadina we know that I1, the current entering into the junction, which is equal to current leaving to the junction. And the rule na enna? You should tell me. And the rule na enna, guys? Tell me. And the rule na enna? Yes, very good. Junction rule. Okay. So in the first question, we got the answer. We got the answer. The fundamental law behind this. Okay. Adu vandu junction rule da in the first law da. Next, explain the validation of law of conservation of energy in Kirchhoff voltage law. So, we know that the work done by any conservative force in a closed loop is 0 agum. So, adanala the sum of the total voltage or voltage drop which is happening in a closed loop is 0 agum. Okay, so adada vandu energy conservation. Okay, energy conservation. Whatever be the energy we have given in the form of potential difference. Okay, whatever be the energy we have given, it is consumed by the circuit. Okay, resistance ipo vandu two resistors irukku, and the resistors ipo vandu I have given 12 volt, and the 12 volt vandu consumed by those resistors. So whatever we have given, it is consumed by the things which is on the circuit. Okay va? So we can say that energy is not created, not destroyed. We have given some energy and the energy utilized. Avloda. Okay va? Okay va? So how the balancing condition gets affected if you are interchanging the galvanometer and the cell in the Wheatstone bridge? Listen the question. Think and give me the answer now. Think and give me. So now Wheatstone bridge, okay, adula vandu we are just changing the galvanometer and the position of cell. So appadina in the balancing condition la what will happen? Very good, Gopinath. It is not going to affect. Yena we know that and the condition na the ratios of the resistors connected. Correct? So adula vandu there is no importance of in the cell order position and the galvanometer order position. There is no such kind of importance. Adinala we can say that there is no effect, or let's say it is not going to be affected by the, yes, very good, there is no change. Okay, so on the balancing condition decide pandradhile in the cell galvanometer there is no influence, and the position it is not at all. We are just checking the ratios of the resistors. That's it. Yes, right now, it's another question. A fast moving neutron collides with the nucleus of plutonium, thereby producing xenon and, what is that? Zirconium along with the neutrons. Write the equation, nuclear fission reaction. Very simple. We should check what is there as the reactants and what is coming as the products. So if we know that we have the plutonium, correct? We have the plutonium and it collides with a neutron. So plutonium plus neutron the reactants. Adukappuram what is the two product we are getting? We are getting xenon and what is that? Zirconium. Correct? So appadina you should balance the atomic number, mass number. What is coming after that? That will be the neutrons will be there. Okay va? Can you just write the equation and can you just give me how many neutrons will be there? Can you just give me the answer? How many neutrons will be there in the reaction? How many neutrons will be there? Yes, it is a sample paper. Very good. 3 neutrons irukum. Yena, it is given here in the plutonium vandu 239 and 94 plus we have the neutron and we are getting 103, 40 and we have 124 and I think 54, right? Which will be giving you. So we should check here 239 plus 1. So what we have over here? 103 plus 124. So how much we need it? Correct? How much we need it? So that is coming as 3. Now I'm just checking over here. Here it is 94. So 40 plus 54, 94 achha. So we can just go for 0. So this is what the reaction. Okay, va? Perfect, perfect. So those who have joined now, don't forget to like, share, subscribe. Yeah, na? CBSE kaga, we are planning a lot of things, not just for physics, chemistry, biology also. So guys, do subscribe and share with your friends. Okay, va? Okay, okay. Impedance, root of R square plus XL minus XC the whole square. So now we have to find the energy released. Energy released in we should first find the mass defect. Yeah, and the energy released is nothing but delta mc square. So first you can just go for the, because yeah, mass is given. Okay, mass is given. So now you can just substitute those values. Can you just check it? Can you go for it? So mass what is going to be the mass? What is going to be the mass? Mass defect. Yes, perfect, perfect, perfect. So you should calculate the mass of the products and mass of the reactants, then subtract. So whatever it is coming, other da in the energy release so we can just go for that. So find it, everybody. Everybody find it. It is coming as 134, sorry. So find the initial mass, go for the final mass, subtract and find the answer. Yes, 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 yes. Okay. So now we can just see that the mass in the plutonium 239.05. Okay. Plus we can go for 1.0086 U. All are given in the atomic mass unit, which is equal to, so you can just find this value. So you can just keep this value M over here. Okay, because anyway that will be gone. Okay, so you can just cancel it. Okay, you can just go for the value. Now you will be having this one. So it is coming as 102 point, sorry, I'm not getting, I can't read the values properly. That is what my problem. And then minus 133.9 plus 3 into 1.008. Okay, so this is what the initial mass, and this is what the final mass. Purinjida. Now you can just subtract. I mean, whatever be the values you are getting, you can subtract now. Can you do it now? Can you do it now? Try it, everybody. Yes, delta M is coming as 0. Yes, we have to multiply with 931.5. Yes. As it is not mentioned, but we have to. Okay. Mass defect, perfect. Mass defect, delta M will be coming as 0.20. Very good, very good, very good. Yes. So mass defect into 931.5 mega electron volt will give you the answer. Purinjida, everybody. And if it is required, you can just go for the, I mean, yeah, this might be enough. You can just find in mega electron volt only. Okay. Okay. So next one, we have a compound microscope consists of an objective lens and a focal length of 0.82 centimeter and an eyepiece lens of focal length 2.9 centimeter. An object is placed 0.91 centimeter from the objective lens. The image is formed at the near point from the eye. Image is formed at the near point. Near point na nothing but the eye is stressed. Okay, va? So in the case we should find the angular magnification. Angular magnification. Can you go for the equation angular magnification? Everybody, what is the equation for angular magnification? For the compound microscope, what is the angular magnification? What is the angular magnification? Yes, Vishnu. What is going to be the angular magnification? Mass of the objective, sorry, magnification of the objective lens into magnification of the eyepiece. Correcta? Correcta? And what is this magnification of objective? It is nothing but the image distance of the objective divided by object distance into this is at the 25 centimeter. Appadina in the mass of eyepiece 1 plus d by fe. D value 25. Okay va? Okay va? So ipa we have the focal length of the objective. Also we have the image, sorry, object distance also, using the lens formula 1 by f, which is equal to 1 by minus 1 by u. Can you find this 1 by v, or let's say v value? Everybody, the compound microscope, Radhika. Okay, compound microscope da. So magnification MO, which means magnification of the objective into magnification of the eyepiece. So magnification of the objective is nothing but the image distance divided by object distance, and this is at the near point. Adanala magnification of the eyepiece 1 plus d by fe. Okay. Okay, now tell me what is going to be VO. What is going to be VO? Yeah, the rest of the values are given. So, I can just go for 1 by F. 1 by F for the value is 0.8. Okay, 0.8. Okay, and plus 1 by U na guys. U value 0.91 centimeter da ana the negative value. So minus 0.91 will give you the 1 by V value. Can you just check what is the V value coming in this case? Okay, so in the U object distance negative da, so you have to go for the negative sign in this case. Okay va? Purinjida everybody? So all of you, don't forget to like, subscribe the channel, also join the Telegram, because we are giving a lots of updates there. Okay, so if you have any confusions also, you can give, you have the access also. So adanale everybody don't forget to join the Telegram channel and subscribe. You have to subscribe this channel as well. Yes, very good, Gopinath, very good. So V value we will be get it as 8.33. It is in the description box. It is in the description box. I'm not the one who is making the question paper, so how could I tell? Okay, so if you are just checking on this question paper, few questions konjam difficult da, ana majority ana questions avlo difficult illa. Few questions little bit not difficult, tricky questions da, ana avlo, not most of the questions. Okay, majority ana question, if you have, we have solved till this question, right? You also understood how the question paper is and how it is for you. Purinjida? Okay, so adanala you can just go for it. So ipa we are getting 8.33. Next we should substitute over here 8.33 divided by 0.91 into 1 plus 25 divided by, and the FE value enna guys? 2.9. So we can just substitute 2.9 as well. Just check it. Check it. Don't forget to like, okay? Don't forget to like. I want 150 likes right now. 150 likes. Can you make it? 150 likes. Our target for the next 5 minutes, we should get 150 likes. Done this one? So, you cannot just approximate for all the values. You should do the calculation. And Neet we can just go for approximations. You should do the calculation properly. We have extra time. Okay, 70 marks question paper da. Each mark 2 minutes. You can do the calculation. So, you can just give me the answer now. What is going to be the magnification? What is going to be the magnification? Okay, I'm just giving the answer. It will be coming around 9. Okay, it will be coming around 9. So you can do it later. Let me go for the next question. So yeah, here they have to asked for draw the ray diagram. So compound microscope order ray diagram, we know it. So, this is the objective size is going to be very small, and we will be keeping the image at a distance, and that image should come in between the focus and pole of the eyepiece. Appadida you should draw. Okay, and that will be giving you the distance. I mean, that will be giving you the, yes, 9.1 something, correct. Okay, yes, perfect. Okay, so do the calculation properly and don't rush for the calculation. Also, I wanted to tell you one thing. If you have done the calculation, do it again. Okay, do it again. Yeah, we know the process, what we need to do, everything we know. Ana simple, a silly mistake will give you a wrong answer. Adu complete. Even if you, in the previous question, if your answer for this object, the image distance for the objective lens, adu wrong aachuna, the whole question is gone. Purinjida? Okay. So, this is the diagram. Next one, define wavefront, define wavelet. What will be the shape of the wavefront intercepted by a large reflecting type of telescope on Earth due to star far away from our solar system? Okay. So, in the question, we should tell what is wavefront. Wavefront na enna guys? Wavefront enna? It is nothing but the collection of points. Okay, which is vibrating on the same phase. Okay, collection of points, locus of all points now, collection of points which are in the same vibration, same phase, or let's say constant phase. Wavelet na enna? Each in the wavefronts allame, we will be, each and every point in the wavefront will act as a secondary source. Adada vanda in the wavelets. Okay, and in the third question, the form of this wavefront. Okay, what will be the shape of the wavefront? It will be definitely planar. In the distance the infinite, right? Distance the infinite. So adanala we can say, we have discussed yesterday the 3 types of wavefronts. Ipa in the object infinity la irundha, we will say it is planar. Okay, very good, very good. So we have another question. Okay, if a point-sized object is having a charge 1 coulomb, okay, object is having 1 coulomb charge, okay, 1 gram mass, projected with a velocity 21 meter per second, correct? From a point 0, 2 centimeter, 0 in the region magnetic field minus 0.1 K Tesla, which spreads in the first quadrant. Okay, what will be the shape of the path followed by the given charged particle? What is going to be the shape of the particle? What is going to be the shape of the particle? What is going to be the shape of the particle? So, you should listen the question. We have a point-sized object having a charge 1 coulomb, mass 1 gram da, projected with a velocity and on the point the projection point 0.2 centimeter. Okay, so in the region of magnetic field, that is equal to the magnitude 0.1. Okay, don't say spherical, this is charge, we should say circular. The shape circular arc. Okay, don't say sphere, because yesterday, day before yesterday, we have mentioned if we are projecting the particle with perpendicular to the magnetic field. Yena idhula magnetic field oda direction enna k. Okay, and on the point of on the velocity it is not 21, it is 2 I cap. I cap na enna, it is moving in a x axis. So appadina it will be perpendicular to the magnetic field k and I. So perpendicular andricha, definitely we know that it will exhibit a circular motion. So idhula we can say that it is a circular arc. Okay, shape the circular arc. At what point it will cross the x-axis? At what point it will cross the x-axis? Circular da, right? So, ipo we should know the radius. Purinjida? Ipo we should know the radius of the circle. Yena, if you got the circle radius, we will get to know when, and the radius da in the x-axis la cut pannu pore. Purinjida? Got it, everybody? So, appadina, what is the equation for the radius? Radius, do you remember, guys? We have studied what is going to be the radius. Ipo idu circular motion la irukku. Idu circular motion la irukku. And the radius we have derived from the centripetal force, which we equated with the magnetic force. Yes, perfect. So now it is the turn for substitution. Pi r square. And the radius perfect. Substitute. Now it is your turn. Substitute the values. And the charge is given, mass is given, and we know all the rest of the values. Velocity also given. So substitute and find it, guys. mv by qb. mv by qb. Mass 1 gram convert to kilogram. Yes, very good. Yes, of course, we need to. Yes, Mithun, perfect. So those who came right now, don't forget to like. Let me check, 150 is there. Oh my god, 153, very good. So now it is our target is to get to 100 likes, okay? My cute cuties will definitely make it to 200 likes. Correct or wrong? Tell me in the chat box. Yes or no? Yes or no? Yes, perfect, Preetham. மறக்காம லைக் பண்ணிக்கோ, ஷேர் பண்ணிக்கோ, சப்ஸ்கிரைப் பண்ணிக்கோ, சேனல்ல டெலிகிராம் சேனல்ல ஜாயின் பண்ணிக்கோ. பாயிண்ட் சோர்ஸோட வேவ் ஃப்ரண்ட்னா ஸ்பிரிக்கலா இருக்கும், ஸ்பிரிக்கல் ஷேப். லீனியர்னா சிலிண்டர். அண்ட் இந்த infinite distance la irundha we will say plane. Theory as I mentioned, one day I have told you, whenever you were very small child, even for one word, even for one letter, you were putting a lot of effort, you are repeating the same thing, okay? And you were just working really hard for that time. And in the time in the physics ivlo difficult, okay? As I mentioned, in the A, B, C, D kaga we cried, we wrote it for multiple times, we repeated for multiple times, we practiced for multiple times. Edukku and the few letters kaga. So ipo in the physics na avlo tough nu ungalke theriyum. And still you are reading and you want to get to remember everything. Adu difficult da. Adukkaga ore oru solution da, you should repeat. Okay, you should repeat, practice. That is only the choice. Okay? Point source na, what to say? Point source na, if you are just comparing with the distance, adu small, and the size small. Avlo da. So idhula r will be coming as 2 centimeter or let's say 0.2 meter. Okay va? So ipo this will be cut with the x-axis with this. what will be the kinetic energy of the particle when it will enter to the fourth quadrant? As we know, in the velocity vandu change agada, correct? We have mentioned the work done vandu 0 da for a conservative force in a complete closed loop, correct? So அப்படினா இந்த kinetic energy work done வந்து change in kinetic energy தான். So அதனால I mean even if it is in fourth quadrant, fifth quadrant or first quadrant, second quadrant, wherever it may be, it will be always same. ஏனா magnitude of velocity வந்து change ஆகாது, direction மட்டும்தான் change ஆகும். அதனால you can find the kinetic energy as half mv square. புரிஞ்சுதா everybody? Purinjida, everybody go for like. We have a target of 200 likes. Okay, 200 likes. Everyone should go for 200 likes. Okay, 200 likes. Yes, half mv square. Still, I want to tell you, I am not the one who is preparing the question paper. என்னால எப்படி சொல்ல முடியும்டா? So adhanala da I have told you Anjana, practice. Okay, in the 10 questions ma'am, one chapter la irundha I have done 10 questions. 11th question I can't do it. Adla vande there is no point. Okay, you should do at least 25-60 questions. Okay, per topic la you have to do at least 15 questions. I mean on the time appadina only we can just improve. Okay, then you tell me ma'am ivlo questions I have done ivlo questions. And then also I can't do the questions. Then I will understand. Okay, something is there with your preparation. I can say that. Ana ipo vande you know how many questions you have done. You know how much time you have spent for physics. Correcta? Correcta? Adada. Sample question paper da. CBSE sample question paper. Thank you Mithun. Thank you Mithun. Thank you. Thank you. Thank you. So, இப்போ வந்து இந்த அட்வைஸுக்கு can I get some more like? Hey, extra 4 likes ada. இந்த இவ்ளோ advice I have given இவ்ளோ advice and still you are saying, ma'am 4 likes மட்டும் we can give. I don't understand. Very good Gopinath, very good, very good, very good. So, இப்போ வந்து we are going for the next question. Next questionல என்ன இருக்கு? A solenoid has a core material with relative permeability 200. Mu R is given 200. The windings of the solenoid are insulated from the core and carry a current 1 ampere if the number of turns are 2000 per meter. Calculate magnetic intensity. Tell me guys, what is magnetic intensity? You guys know the equation. What is magnetic intensity? H is equal to, tell me what is H is equal to? Everybody, what is magnetic intensity? H is equal to, எப்படிரா என்னால அதுக்கு ஆன்சர் பண்ண முடியாது. Yes, perfect. It will be coming as Ni. So now you can substitute the values. Go for it. What is N? N is already given 2000 per meter. Okay, I value na 1 ampere. So what is the value? What is the value for the magnetic intensity? Magnetic intensity. Very good Gopinath, very good. It will be coming as 2000. Okay, va. Next one we should know magnetic field. What is going to be the equation for magnetic field? Mu 0, mu R, H. H you already found. So mu naught you know already the value 4 pi into 10 to the power minus 7. Mu R value is already given in the question. So go and substitute guys. Let me know the answer. So innum few likes are left for 200 likes. So innum few people were not even selfish. You are not even giving like. You are not even subscribing. Thank you, Galaxy. So if you should substitute the values. Mu naught, mu r h. Mu naught 4 pi into 10 to the power minus 7. Mu r it is already given in the question. Adoda value enna? 200. Okay. And h we already got it 2000. So substitute everybody. Yes, Gopinath. Yes, Gopinath. Yes. Perfect. So, if we can go for 4 pi into 10 to the power minus 7 into 200 into 2000. Okay, va? Okay, va, everybody? Yes. It will be coming as 0.5. Okay, now let us go for the third one. Magnetization oda equation anna. Magnetization oda equation anna, guys. You know it. Yes, perfect. Everyone has given the right answer. Magnetization. What is the equation? Mu r minus 1 into h. Magnetization is nothing but mu r minus 1 into h. So you can go for that as well. So in the equations, in the magnetism and matter chapter la you don't need to study much. Ana few terms irukku, and the terms and the equation is very important. Okay. So magnetization. Done? All done? 20 more likes for 200. Yes. Okay. So, we will be getting 199 into 2000. Okay. Here, all the formulas are here. Da. Yes. Perfect. Very good. Correct. Okay. Now let us go for the next question. A conducting coil 50 turns and area 5 by pi centimeter square is rotating along the axis of a solenoid 50 centimeter and 2000 turns, carrying a current of 5 ampere. What will be the value of maximum EMF generated? And the maximum EMF generated equation enna? Maximum EMF NAB omega. Purinjida? Okay, va? So now you can just substitute for B. Yena B what is going to be the B value? What is going to be the B value? We can go for mu 0 Ni. It is a solenoid, correct? So now we will be going for mu 0 Ni omega. N you can replace and you can do it. Likes Marakama, like. Few more is there. Few more. Why? I don't know why you people are like this. Very good. So, now the conducting coil order turns 50, area na pi into, what is the area is already given. Okay. So, area is given as 5 by pi, correct? Area, yes, into 10 to the power minus 4, mu naught 4 pi into 10 to the power minus 7, n 2000 turns in 0.5 meter, 50 centimeter la 2000 turns. So, appadina unit per, number of turns per unit length 2000 divided by 0.5 into current 5 into omega. Omega is given. So omega, you can keep it as omega. Nothing is given for finding omega. So you can keep it as omega. Till we are finishing this question paper. Okay, so you can keep omega as it is. Yeah, and the omega value, we cannot directly find the omega because in the values, there is no enough values for finding omega. Okay. So almost approximately it will be coming as 2 into 10 to the power minus 3. Omega also will come, as I mentioned. This cannot be directly found. So you can keep the omega value. Okay. So next one, when an external, this is the case study problem da. So you should understand what is the scenario given. Okay. When an external voltage is applied across a semiconductor diode such that P side is connected to positive terminal, N side is connected to the negative terminal of the battery. So we will call it as forward biased. Okay. So appadina we can say that the applied voltage mostly drop across depletion region and voltage drop across P side and N side of the junction is negligible. When external voltage is applied across the diode such that N side is positive, P side is negative, it is said to be reverse bias. The applied voltage mostly drop across the depletion region. Okay va? Okay va? Purinjida? So, you should understand what is the given scenario. Okay? Okay, maybe the powers may change. You just check it. Okay? I think it will be coming as -7. Yeah, fine. Let's go. Okay? So, we understood a semiconductor PN side, PN junction diode. So, first we have given the forward bias. So, on the time if you are giving the apply voltage, mostly drop across the depletion region and the voltage drop across the P side and N side of the junction is negligible. When an external voltage is applied across the diode such that N side is positive, which means we are giving reverse bias. And the time the voltage drop it is through the depletion region. Now we are going for the question. These are all we know it. Now let us go for the question. Let's see. Okay. So, now the germanium silicon, we have two diodes are there, okay, conducting at 0.3 volt and 0.7 volt respectively. So, in the following figure, if germanium diode connections are reversed, then the value of V0 changes by. We need to know how much it is changed. Okay, wow, how much it is changed. So, how we will be finding this? In the question, how we will approach. So, if we are giving 12 volt battery, correct? We are giving 12 volt battery. So, in the first case, in the silicon and germanium, forward bias. Now we know that in the diode, in the diode turn on, what we need to do? We need to give we know there is a potential barrier. It is mentioned 0.3 for germanium, 0.7 for silicon. Understand in the concept romba important. So, in the diode, if there is, if the current should go, what we should do? For the germanium, we should give more than 0.3. For the silicon, we should give more than 0.7. And correct, we have more than this 12 volt we can. So, now forward bias, I am not thinking about reverse bias. Yeah, we need to find the change, correct? Okay, we need to change, we need to go for the, yes, perfect answer, correct. Okay, so now listen why it is so. So, now in the two diodes forward bias and least voltage required, the small potential drop will be for the first diode, germanium, 0.3 and silicon, if you are just checking on silicon, that is 0.7. So just imagine in the current in the voltage it is, current it is flowing through the circuit. In the current has reached here. In the current reached here. If it is looking at the diode, in the germanium 0.3 enough. Okay, so in the 0.3 agna moment illa and the moment illa what will happen in the current vandu it will flow through germanium. Yena silicon ku 0.7 venum, 0.7 venum, and in the germanium 0.3 enough. So first in the first scenario what will happen on the potential drop vandu it is due to the germanium. So now I can say that 12 minus 0.3 which will be giving me 11.7. Purinjida? Yes or no? Let me know in the chat box. Yes or no? Okay. So in the first case la forward bias la anga irukira potential drop na 0.3 da. So we will be getting 11.7. Ipa vandu reverse la. Okay, ipa vandu reverse la. Reverse aachuna what will happen? There is no current to flow through it. So this current will come, it will reaches the junction and it cannot travel through germanium. Adanale it will go for the other path, that is nothing but 0.7. So appadina and the time 12 minus 0.7 will come, so that will be coming as 11.3. Okay, ipa vanda they have asked this change and the change vanda 0.4. Correct answer option B. Whatever you said is correct. Okay va? Okay va? Understood? Yes, of course. Okay. 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 Now let us go for the second question. Based on the same question, we can see the value of V0 and ID for the network R. We need to know the current passing through the diode as well as we should know the potential as well. So can you find it for this question? Yes or no? Tell me. So inga kuda 12 volt da we are giving and there will be a potential drop across silicon as well as germanium. So what is after that? Okay, in the voltage vanta it will be coming to the first diode, anga voltage break, voltage drop irukum, yena idu vandu series. Before that we have done for the parallel connection. Okay va? Okay va? Okay va? Okay, so ipa vanda we understood there is a potential drop across silicon, there is a potential drop across germanium. Got it? Got it everybody? Okay, so ipa vanda we know that silicon and germanium is having a potential drop. Adanale total vanda 12. அது வந்து it will be we need to subtract. இது வந்து 0.3, இது வந்து 0.7, அதுதான் வந்து V0. Okay, so we will be getting in the V0 வந்து what is going to be V0? What is going to be V0? இது வந்து 11 volt. Okay va? So you can just இதில இருந்து you got the answer. ஏனா 11 volt na option D da. So you got the answer. ஏனா வந்து we should know how we will be finding the current as well. So இப்போ வந்து how we will be finding the current, guys? How we will be finding the current? Current dot equation enna? Current dot equation enna? Current dot equation? It is nothing but V0 by R. So 11 by R na 5.6 into 10 to the power 10 to the power 3. 10 to the power 3. So we will be getting 1.96 milliampere. Perfect, perfect. Everybody super, super. Let us go for the next question. Are you guys ready? Ready now? You can give me a fire in the chat box. Let me just check who all are ready. If good number of students are in there, we can go for the next question. Yes, 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 only 5. Yes, 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 yes. Perfect, perfect. So let us go for the next question. So same base. The circuit shown below contains, oh my god, I'm getting old. I can't even read. Okay, contains 2 ideal diodes, each with a forward resistance of 50 ohm. If the battery voltage is 6 volt, the current through the 100 ohm resistor. So we should know what is the resistance through this ohm. This resistance. So ipo vanda you can see in the, I mean, this one is in the reverse bias, so just ignore this. This is not required. ஏன்னா reverse bias na there is no current flow. So அதனால அந்த ரெசிஸ்டன்ஸுக்கோ அந்த டயோடுக்கும் there is no importance. அதனால you can completely remove. இப்போ வந்து you have D1, you have 150 ohm, you have 100 ohm, இது வந்து 6 volt, and அந்த டயோடுக்கு வந்து there is a resistance, forward resistance, அது வந்து 50 ohm. So இதுதான் வந்து our question. So now you can just do the question. Now you can do it. Perfect. Shija, right? Yes. You need to I mean, you need to get my age, right? I won't tell, I won't say anything. So இப்போ வந்து we have the circuit like this, 6 volt power, I mean voltage we are giving, and in the diode la irundha we have 50 ohm, இது வந்து 150 ohm, இது வந்து 100 ohm. So if you are removing this in the 3 resistance வந்து series la, so அப்படினா the equivalent resistance வந்து 50 plus 150 plus 100, அப்படினா we can say 300 the total resistance. அப்படினா you can go for the current na enna V by R, so V வந்து 6 divided by 300. Now you got the current. புரிஞ்சுதா? Everybody understood? Yes or no? Yes or no? Perfect, super, correct. Okay, it will be coming as 0.02. இப்போ வந்து we are going for one more question. In the figure, the potential difference between A and B. We need to know the potential difference between these 2 points. அப்படினா how we will be finding it? How we will be finding it? The diode, they didn't even mention any resistance, so you can, it is in forward bias, so you can just make it as a single connecting wire. அப்படினா இந்த 10 ohm வந்து series ஆகும். It will be in series. Check again. What is the potential across VAB? Wow. I didn't even notice. Thank you, Jenny. Thank you. And also, I should say thanks to everybody. Okay. So, இப்போ வந்து you people are all giving a lots of love. Okay. I should say this. ஏன்னா இப்போ வந்து இன்னும் I mean in very few days we have almost reached 25k. Not almost, we are at 25k. Okay, so அது வந்து I should I mean not we should say thank you to everyone. ஏன்னா அவ்வளோ love you guys are giving, and every day கிளாஸுக்கு அப்புறம் we were talking about this only. நம்ம ஸ்டூடெண்ட்ஸ் வந்து அவ்வளோ they were giving a lots of care, they were giving a lots of love, everything. Thank you so much guys. அதுக்கு வந்து I mean whenever we are doing something, அதுக்கு வந்து appreciation கிடைக்கும் போது I mean the happiness வந்து double triple ஆகும். ஓகேவா? ஸோ அந்த மாதிரி இப்போ I'm standing with a lots of happiness, and I mean I'm getting the appreciation whenever you're giving a like, whenever you're giving I mean good comments. அந்த Sunday sessionக்கு அப்புறம் I was just going through the comments. அது வந்து like I literally cried. அந்த மாதிரி அவ்வளோ love, அவ்வளோ care. So அது வந்து thank you so much guys, thank you so much. Okay, and I cannot say all these things in words. என்னைக்காவது if we can meet, definitely I mean you can experience how happy I am. Okay, thank you guys, thank you so much. Okay, let us continue. இதுதான் வந்து energy. Okay, every day I'll feel like okay wow, okay perfect, இது மட்டும் போதும். அந்த டைம்ல you people will be giving a lots of energy, so I will be get like yes, let's do it. So இப்போ வந்து we are going for this question. Okay, So in the question in the figure potential difference across VAB. As I mentioned, on the diode complete we can just ignore. So we have right now 10 kilo ohm, 10 kilo ohm will be coming in the parallel connection. So appadina I can just replace this one, and now this capacitor, this resistance the 5 kilo ohm. Okay, resistance the 5 kilo ohm da. So appadina we can say that we have 10 kilo ohm as well as 5 kilo ohm. We need to find the potential difference. We need to find the potential difference. Can you find it? And the potential difference na enna guys? Very simple. The current will be there and the resistance is there. So on the potential VAB the current flowing through the circuit into R2. Okay, so you should find I. I na enna? I na enna? What is going to be I? Tell me what is going to be I? What is going to be I? The current passing through the circuit. It is nothing but V by R1 plus R2. So I'm just rewriting here V divided by R1 plus R2 into R2. So V na 6, R1 plus R2 na 15 into R2 na 5. So now you can do it. This is 30. Very good, very good, very good. Go for it. Check the calculation. Yes, this is a sample paper. CBSE sample paper da. So everybody don't forget to like, share, subscribe. Next tomorrow we are going to solve PYQs, numericals da we will give more importance. And adukapro on Thursday we are going for Thursday lana, yes, in the mega marathon. Okay, so quick revisions irukum, problems irukum. It is going to be a summary for, it is a quick revision. Okay. Yes, perfect. So it is going to be 10. So adha in the potential across AB. Okay, va? So now let us go for the next question. Again, case study da. So we should understand whatever be the things given. Can you just read this? Okay, can you read this? Photoelectric effect is the phenomenon of ejection of electrons when the radiation of suitable frequency is made to fall on the surface of a metal. When light of suitable wavelength falls on the emitter plate, gives in the diagram, the photoelectrons will emit. In the photoelectric effect we are discussing over here. Okay, va? Then where we have stopped? Okay. So then the electron will fall on collector. The photoelectric current of the order of a few microamperes can be normally obtained by the device given in the figure. Okay, so that is nothing but our ammeter. The device given convert a change in the intensity of illumination into a change into photocurrent. Then the current can be used to operate control system and light measuring device. The device are made up of metal with low ionization enthalpies, or let's say work function, less work function. So on the work function is given, that is nothing but 6.35 electron volt. Work function is given as 6.35. Infraradiation of frequency 3 into 10 to the power 11 hertz is used as incident radiation. Determine the reading of microammeter, justify mathematically. So you cannot just simply write the answer. You should prove why the ammeter is showing this reading. So how we can just check it? We know that in the work function h mu naught. Correct? H mu naught. So you should check you should find the mu naught, or let's say threshold frequency. Okay, work function is given, so you can find the threshold frequency, and the threshold frequency is less than that of the frequency of the incident radiation na adilirundu photocurrents irukum. So the ammeter will show the readings. this is greater than the incident frequency. Now what will happen guys? In the current zero. ஏனா electronsக்கு வந்து it cannot emit or it cannot escape from the metal surface. ஏனா அதுக்கு வந்து ஒரு minimum energy இருக்கணும். புரிஞ்சுதா? So now you should tell me what is the threshold frequency. Threshold frequency எப்படி we will find it? Work function divided by h value. H value na Planck's constant. Planck's constant na 6.64 into 10 to the power minus 34. So இப்போ வந்து you can substitute and you can find it. It is there. You don't need to study the derivations and everything. ஆனா வந்து அந்த equations, everything is important. In the NCERT, I mean, in the syllabus I mentioned as qualitative treatment. Okay, so adanala you can just go for the contingents. You should know the concept, you should know the contingents. Okay, that's it. Got it? Threshold frequency. Threshold frequency வந்து mu naught, which is equal to work function divided by h. Work function I think 6.35 into 1.69 into 10 to the power minus 19 divided by 6.64 into 10 to the power minus 34. Okay. So இப்போ வந்து while you're doing this you will get to know in the frequency வந்து less than the threshold frequency. அதனால what will happen guys? அதனால what will happen? In the threshold frequency வந்து less. So அதனால definitely there is no current. ஏன்னா அந்த electronக்கு threshold frequency, at least it should get the threshold frequency. I mean அந்த work function energy இருக்கணும். இல்லனா it cannot excite from the metal surface. அதனால வந்து ammeter will show 0 readings. So இப்போ வந்து in the given diagram, if the terminal B is shifted towards the left, then how it will affect the reading of microammeter? How it will affect the reading of microammeter? How it will affect guys? Of course, polarity changed. அப்படினா what will happen? In the electronic, it cannot come to the collector plate. ஏன்னா அவ்வளோ attraction இருக்கு இங்க இருந்து. So அதனால வந்து what will happen? இந்த photo current ஓட amount வந்து reduce ஆகும். So ammeterல reading வந்து it will reduce and eventually it will come to 0. Okay? So that is what is happening in the second case. If the intensity of incident radiation is doubled, what will happen to the kinetic energy? Intensity doubled. Intensity increase ஆச்சுனா we know that number of photons increase ஆச்சு. கரெக்டா? Intensity increase ஆச்சுனா number of photons increase ஆச்சு. Number of photons increase ஆச்சுனா more number of electrons will be ejected, right? More number of electrons can because each photon will interact with one electron. So அதனால photon, one electron, one photon, one electron, one photon. So அதனால intensity double ஆச்சுனா double number of electrons will flow. I mean அதோட impact we can say that அந்த current, okay, photo current will increase. ஆனா வந்து kinetic energy வந்து extra energy இருக்கணும். கரெக்டா? Okay, work function ஓட விட it needs more energy for the kinetic energy, or let's say to travel. அதனால intensity increase or decrease, it is not affecting the kinetic energy, it remains the same. Perfect. மறக்காம like பண்ணிக்கோ guys. So next one, the derived lens makers formula. Okay, derived lens makers formula. So next one, our target for like is 250. Okay, so in the next 5-10 minutes, let us expect we will get this or what. Okay, so let's see. So இப்போ வந்து derived lens makers formula. So அது வந்து we have already done. I'll just brief you. Okay, so இப்போ வந்து we have a lens over here. Correct? We have a lens over here. So இதுல வந்து first surface இருக்கு. So இந்த light, incident light will fall on the first surface. அதுக்கப்புறம் it will have a refraction. அந்த refractionக்கு அப்புறம் it will create an image over here. Or let's say அந்த refractionக்கு அப்புறம் we will just extend that line. Okay, ஆனா வந்து இந்த second surface இருக்கு. Again ஒரு refraction. கரெக்டா? Rarer to denser medium. First rarer to denser medium. And again denser to rarer medium. So here we have two. Okay, here we have two refraction happening. First surface inala, it is creating an image over here. I'm calling it as I dash. Okay. Second surface inala, and the final image is formed over here. Next one, for the first surface and second surface, we should apply the equation N2 minus N1 divided by R, which is equal to N2 by V minus N1 by U. In the equation, we will apply for both the surface, and that will give you first surface, and for second surface we will apply, and we will be getting a relation, lens makers formula. So on the relation 1 by F, okay, 1 by F, which is equal to N minus 1, or let's say N12 minus 1. So basically we used to say N on the first medium it is nothing but air. So adanala we can just say N, or let us say to be specific N21 into 1 by R1 minus 1 by R2. Okay, R1 na, so whenever you are writing the equation and everything, you should make sure, ipo vanda R1 na enna, in the radius of curvature of the first surface of the lens. Okay, R2 na for the other surface, refractive index, N na the refractive index of the lens, F na the focal length. So you have to write each and every terms, then only you will be getting the score. Okay va? Okay va everybody? So let us do one thing. Let us go for a quick 10 minutes break. Adukapram we can just solve. Again we have heavy problems is there. So let us just do after some 10 minutes. Ipo vanda 7:53, correct? Okay. So let us just meet at okay. So after 10 minutes, not 10 minutes, correct? 53, right? 7:05 is enough. Okay. So we will meet at 7:05. Okay, 7:05 everyone should come back and go for a refreshment. Don't sit with the mobile. Okay, just go drink water, walk around and come back. Adukulla I will also take some water. I will drink some water and I will also come. Okay, so let us meet at 7:05. Let's do the rest of the difficult questions. Okay va? Okay va? Sorry, 8:05. Thank you. Bye. See you guys. See you. So sharp 8:05. Hello again. Are you guys here? Yes or no? Let me know you guys are there or what. What you guys are doing? Refreshment is done. Okay. So also guys, I just wanted to tell you one thing. I have made a video for your OMR sheet filling. It is very important. So go through it. Yeah, we have studied, we have done that, we have done this, and definitely if there is a mistake happened in the OMR sheet, there is no point in the efforts, right? Whatever be the hard work we have done. Adanala, you should watch after this class. Okay, everybody? Okay. So, we are going for the next question. Okay, wow. So, we have a dielectric slab of thickness T, and it is introduced between the plate of parallel plate capacitor of area A and separation D. Find the expression for the capacitance with the dielectric slab. Okay, so how we will be starting? Again, I'll just go for a brief idea, so you can I'll just give you the steps. So in the potential it is due to two things, right? So first one let us say this nama parallel plate capacitor. Idhula I am placing a dielectric material. So adoda length T, in the separation D. Okay, so in the electric field electric field into the distance adudha in the what is a potential. So adanal I can say that this will be E into D minus T. Okay, and plus electric field in the dielectric medium into the thickness of that. Right now we know E is nothing but Q by A epsilon naught D by T. Okay, plus E dash na enna E by K. So I can just go for Q by A K epsilon naught T. So ipo we are just taking Q by A epsilon naught outside. So we will be getting T minus D plus T by K. Okay, so now what you need to do? Now you know we got V. So adanala C kya gaya? We can just go for Q by V. So then you will be getting A epsilon naught divided by D minus T plus T by K. Okay, wow, that's important derivation. So, now the option, B question, we are going for it. A copper sphere of capacitor C is dropped in ocean. Will the capacitance of the sphere increases or remain same? Justify. You can give me the answer. Simple question. Now, in the medium change. Capacitor, it will depend upon the medium. Correct? And if the medium change aachuna, what will happen to the capacitance? Will it increase or remains the same? Of course it will change. Correct? Yeah, capacitor is depending upon capacitance is depending upon the medium. Adanalatha the epsilon. We have the epsilon. So appadina in the copper sphere capacitor order, capacitance enna? Capacitance enna? If it is in vacuum and the capacitance 4 pi epsilon naught r. Ana ipo 4 pi epsilon naught epsilon r into r da. So definitely capacitance will increase. And also you should add one more thing. Definitely in the water molecules polarization will happen. Correct? This is going into the ocean. So water molecules polarization will happen. Adinale again electric field will be reduced. Adinale potential will be reduced. Again due to that capacitance will increase. So adu kuda you should check. Okay va? So you can just write two things. Idhula vande capacitance order formula 4 pi epsilon naught epsilon r into R. Okay, it is depending upon the medium. Second one enna polarization in the water molecule polarization will happen. Adinala there will be an electric field which is in the opposite direction. Adinala it will reduce, potential also will reduce, and capacitance will increase. Now let us go for the one more question is there, I guess. Yeah, right? Yeah. A capacitor is connected across a source of potential difference V, and then the separation D between the plates is increased using insulating stick. Plot V versus D graph. How will be the graph? Think and tell me, guys. Think and tell me. Polarization na in the water molecule I mean, it will go for the polarization. Okay, va? So in the polarization, now whenever we are, I mean, giving an external electric field, there will be an induced EMF inside the material. So adanala, in the water molecules will be get polarized. There will be a, there will be an induced electric field, not EMF, okay, in the opposite direction. So on the net field vandu reduce agum. Okay, net field reduce agumna, we can say potential also going to be reduced. Okay, so adanala we can say the capacitance vandu increase agum. Illana and the equation basis la you can just explain. Purinjida? Okay, so ipo vandu what we are doing in the capacitor, we have connected with the potential difference V, and the separation of these plates vandu D. Ana vandu now we are doing something. What? We are increasing the separation. Appadina, how will be the graph? How will V varies with D? How will be the graph? Tell me, guys. Marakama like paniko. Nama target vandu 250. Okay. I'm getting a lot of hearts and all those things over there. Yes. Okay. Now you can tell me how will be the graph. Everybody, tell me how will be the graph. V versus D graph. Konjam questions da irukku. Hardly 4-5 questions da irukku. Adukapram in the session mudinjidu. Who was 5 minutes late? I am on time. 8:05. Tell me how will be the graph. Yena, in the distance, whenever we are increasing the distance also, I mean, we are giving a potential difference, correct? We are giving a potential difference across the capacitor, which means the potential across the capacitor vandu always remains constant. Okay, va? So, appadina, the graph will looks like this. Okay, graph will looks like this. V is not going to change with D. If D increases or decreases, that is not going to affect the potential. Yeah, now we are giving the constant potential. Idoda answer in the CBSE site la irukkiradhu wrong da. So you should check this is the correct answer. So ipo vandu potential should be always constant. Yeah, now we are giving the potential, constant potential. Adanala the distance increases or decreases, adu vandu it is not a matter. Okay, so graph vandu ipdi irukum. Ipo vandu let us say we are removing the battery. Okay, I'm removing the battery and the constant potential I'm not giving. And the time la enna agum? In the charge vandu constant agum. Okay, va? If we are removing the battery, charge vandu constant agum. And the time la, if we are plotting the graph will be like this. Purinjida everybody? So you should know when will be the graph constant, when the potential is given. Potential is given na. If let's say I'm giving a battery, I have applied with a battery. So 12 volt na adita constant. Okay. Once I removed, then what will happen? In the 12 volt, when I'm applying in the 12 volt, what will happen? In the charges vandu it will still flow. Once I removed, charges vandu constant agum. Purinjida? Understood? So idoda answer vandu it will be horizontal to the x-axis, or let's say horizontal to the distance axis. Okay, va? Next vandu if we have removed the battery, and the diagram will be like this, the graph vandu it will be like this. Next vandu define the angle of deviation in a prism. It is nothing but, let us say, ipo idudha namma prism. Okay, so ipo when the light is falling like this, after that here there is a refraction, here there is a refraction. Ipo when this is going in a straight line na, in the emergent ray will make an angle with the incident ray. Okay, emergent ray will make an angle with the incident ray. Adudha vandu in the angle of deviation. Okay, va? Everybody should like, share, subscribe. Yena physics ku mattu illa, for all the subject, for chemistry, biology, we are giving the classes, not just for the CBSE boards, for the Neet exam as well. Adinala marakama like panniko, share panniko, subscribe panniko, Telegram la join panniko. Okay, so the one that we should change it as a music. Okay, so if you want to obtain a relation for A plus delta E, which is equal to I plus E, which we have already done. Again, I will just brief you. So this is the number A. Okay, so if I am going for normal, Okay, normal for this surface as well as normal for this surface as well. Okay, so இது வந்து R1, இது வந்து R2. Correct? Okay, va? So first வந்து diagram important da. In the incident ray, emergent ray, all the direction you have to specify. இப்போ வந்து I'm just calling this as N. அப்படினா I can say that angle A plus angle N வந்து 180 degree da. ஏனா இது வந்து quadrilateral. Right? Next வந்து we know R1 plus R2 plus N வந்து 180 degree. ஏனா இது வந்து triangle. Correct? Okay, so இது வந்து incident angle da. Okay, இது வந்து emergent angle da. Correct? So இப்போ வந்து I can just say that angle N in both the cases. So R1 plus R2 வந்து it is nothing but equal to angle A, or let's say angle of prism. So அப்படினா now you have to go for one thing. You should tell me what is this angle. I'm just calling it as delta 1. ஏனா இந்த first surface இந்த incident ray வந்து it is falls on the first surface. அப்படினா இந்த angle வந்து delta 1. Correct? And in the deviation for the first case. And this is nothing but delta 2. Now I can say delta 1 plus delta 2 which is equal to the deviation. Purinjida? In the sample question paper, if you are solving, you will get more confidence. Adanala I'm telling you, please focus and try to understand each and everything which we are explaining over here. Okay? Like marakada. So இப்போ வந்து we got delta 1. ஏனா இது வந்து interior angle of a triangle will be equal to the sum of the interior angle which is equal to the exterior angle. புரிஞ்சுதா? Exterior angle. So delta 1 plus delta 2 which is equal to delta. இப்போ வந்து we should write delta 1 and delta 2 in terms of incident angle and emergent angle. So இப்போ வந்து இது வந்து total. Okay, இது வந்து total I da. If this angle is I, this is also going to be I. If this is E, this is also going to be E. So அப்படினா you can just write what? Delta 1 is nothing but I minus R1. Delta 2 is nothing but E minus R2. புரிஞ்சுதா guys? Tell me a yes or no in the chat box. Okay. So அதுக்கப்புறம் if you have written delta 1 and delta 2, you can substitute over here. Okay, you can substitute over here. Delta 1 and delta 2 you can substitute. And in the minimum deviation kaga, what are the conditions guys? What are the conditions? I is equal to E. Correct? Also R1 must be equal to R2. Okay, so அப்படினா we can just go for the Snell's law once you got the incident angle and the refracted angle. So refracted angle kaga we will be writing A by 2. Incident angle kaga we will say A plus delta M divided by 2. Okay va? So this is very simple. Delta வந்து I minus R1 plus E minus R2. So this will be coming as I plus E minus R1 plus R2. We know R1 plus R2 na A. So I plus E minus A வந்து we will be getting the deviation. Minimum deviation kaga we will be getting this thing. So R1 plus R2 which is equal to 2R which is equal to A. Appadina R na A by 2. So in the equation I'm going to make a change for minimum deviation. Idu vandu 2I minus A. So you can just write delta M minus A divided by 2 vandu I. Correct? So now you can just go for the Snell's law. Sin delta M minus A divided by 2 divided by sin R which is nothing but sin A by 2 which is equal to refractive index. Purinjida? Yes or no? Yes or no? Tell me in the chat box. Okay, so we have done the condition also. Now we are going for the next question. What is the question? If a charge 1 microcoulomb is placed at the origin, okay, those who are coming new, subscribe the channel. I'm telling you, this is going to be, this is going to be the channel. If you have subscribed the channel, you are going to get a lots of good quality contents. Okay, so if a charge of 1 microcoulomb is placed in a origin and another charge 3 microcoulomb is placed at 20 meter in an external electric field 40 volt per meter with the electric potential at the origin to be 0. Find the electric potential energy. So this is something like we have mentioned, we have studied when we discussed about the second chapter. the electrostatic, the potential energy in an external field. Do you remember the equation? External field il irukumbodhu and the potential energy enna? And the potential energy enna, guys? Tell me, we have studied this equation. Adoda equation enna? Yes, Q1 V1 plus Q2 V2 plus K Q1 Q2 divided by R. I hope you guys remember. Those who have attended that session, I hope you will remember, because yeah, we have explained why this Q1 V1 and everything. Correct? So ipa vanda in the, this is the field lines. Idha vanda origin. Okay, idha vanda origin. Inga V1 vanda 0 and this is 20 centimeter, and we can find the potential also. Correct? Because we have the electric field. Yes or no? Yes or no? In the potential electric field order relation, and guys, tell me in the chat box. Potential and this potential and what is this? Electric field. Okay, that's a relation, and tell me in the chat box. I need to get what is the relation? Potential will be equal to electric field into the distance. Correct? So appadina we are going to substitute the values in this equation. Substitute the values. So U, which means Q1 enna 1 microcoulomb. So 1 into 10 to the power minus 6. I'm not getting the response. Okay, I want more response. Why you people are went for sleep? Okay, so if I want the Q into V1 at the origin, it is mentioned 0 plus Q2 na 3 into 10 to the power minus 6 into V2 kandupidikkiradhukaga we have the equation V2 which is equal to the field value vanda 40 into distance vanda 20 meter. So I can go for 40 into 20, which means and idu vanda negative da yena field and potential vanda opposite direction. So adanal I can say that this is equal to minus 800 into K value na 9 into 10 to the power 9, Q1 na 1 into 10 to the power minus 6, 3 into 10 to the power minus 6 divided by the distance 20. So idudha vanda the calculation you need to do. Purinjada? Yes or no? Tell me in the chat box. Everybody, just a direct substitution da. We have already studied the equations, everything. So just the substitution. Okay, wow. Yes or no? Tell me in the chat box, everybody. Are you guys there? Can I get some fire, please? Please. Ipo vande enakke energy illa because you people have, I think you people were went somewhere. Where are you guys? Yes, MS Dhoni only there. I want Virat Kohli. I want who else? Surya Kumar. Right. We want all the people. Where are all the rest of the people? Okay. So now we understood how to find the potential energy. So do the calculation, you will be getting it. Now I'm going for the second one. If one charged particle is moved from A to C, then to B, another charged particle of equal magnitude is moved from A to D, then D to B. In uniform external magnetic field, than for which change particle more work will be needed. More work. So we are talking about conservative force. Correct? So in the conservative force, the work done depending upon the initial and final points. Correct? So appadina, oh my god, I got this much of fires and all. Oh my god. I think there is a lag in the chat. Let me just fix it. Otherwise, I will feel you people are not responding. Why my students are doing like this? Yes, perfect. So marakkama subscribe panniko, marakkama like panniko. Still it is, oh my god, till it is not 250. Why this? Yes. Now only I'm getting all this fires. Okay, so ipa we know that in the work done it is depending upon the initial and final points. So work done is not required more. The same for both the cases. Yena adu path depend pannala. Ipa next part. Electrostatic potential is constant throughout the volume of the conductor, has the same value on its surface. Why? Why? Yena, we know that inside the electric field vanda 0 da. Okay, electric field vanda 0 da. Adinala, definitely we can say that the field lines, it cannot penetrate inside the conductor. Adinala, we can say that the electric field is 0, and electric field and potential, the relation is this, dV by dr. Appadina, electric field 0, dV by dr will be 0. Appadina, V will be constant. Done. Next one, state the working principle of moving coil galvanometer. Yes, tell me guys, yesterday we have studied. Yesterday, correcta? Correcta? In the moving coil galvanometer, not yesterday, day before yesterday. Yeah. Tell me what is the principle? Now we are keeping a rectangular coil in a strong magnetic field. Appo what will happen? It will experience a torque. Correcta? It will experience a torque. And in the needle vanda deflect agum. Correcta? Needle vanda deflect agum. And the deflection vanda proportional to the current I. Okay va? In the deflection of galvanometer vanda proportional to I. Whenever we are keeping in a rectangular coil in an external magnetic field, it will experience a torque. And on the torque we have mentioned that it is connected to a spring, and due to this rotation in the spring, it will experience a twist, and the twisting angle, okay, and the restoring torque will be there. Correct? Restoring torque will be there. Appadina, we can say that and the torque NIAB sin theta maximum. To get the maximum, we are using cylindrical magnets. Yeah, I mean, all the time in the magnetic momentum, in the magnetic field, always. I mean, if it is not happening with one field line, another line, we will be getting the maximum, or let's say it will be always perpendicular. Adukagata, we are using the cylindrical magnets. Always in the magnetic moment and magnetic field will come as perpendicular to each other. Adanala, we can say NIAB sin theta. Okay, adu vanda NIAB. Which will be equal to what? Which will be equal to the restoring torque. Okay, va? So this is the basic idea of the moving coil galvanometer. Okay, so ipavanta we will be getting the torque which is equal to this restoring torque. So we can just equate. So apavanta we will be getting NAB by K into I, which is equal to 5. In the part one, the constant da, so we will be getting I, which is equal to, I is proportional to 5. Okay va? So if a galvanometer of resistance 49.5 has a range of 0.05 ampere, what will be the value of resistance needed to convert ammeter of range 5 ampere? Can you do this? Can you do this? Because to convert it as an ammeter, we should connect a shunt resistance. And the shunt resistance or a value, and guys, tell me in the chat box. And the shunt resistance, how we will be finding the shunt resistance? How we will be finding the shunt resistance? Adoda equation anna. To convert galvanometer into ammeter, what is going to be the shunt resistance? What is going to be the shunt resistance? Yes, tell me what is going to be the, how we will be finding it? It will be nothing but Ig into the resistance of the galvanometer divided by I minus Ig. Purinjida. So now you can give the values, correct? So in the current one, in the galvanometer, the resistance one, the 49.5, I one the 5, and in the galvanometer, the current one, the 0.05. Can you substitute? Can you substitute and can you find it? Yes or no? Yes or no? 0.05 into 49.5 divided by 5 minus 0.05. How many more questions? Let me check. 2 more questions. So 2 more questions. Sample question paper, CBSE sample question paper over. Okay. Yes, check it. So, I'm going to substitute the values. IG வந்து 0.05 into 49.5 divided by 5 minus 0.05 will give a resistance value that is equal to 0.5 ohm. Correct. Yes. Who has given? No. What's your name? Okay. So, Bhavanda, we are going for the... What question it is? If I am the one who is making the question paper, the same I will go. This is a sample paper which is given by CBSE boards. So, you can just try, because before the exam, this is the practice. Avloda. Okay. Marakama like paniko, guys. Marakama like paniko. In the galvanometer diagram, if you are just going for that question principle, for that you should go for it. Okay. So, if we have a question, an input potential of 200 sine 100 pi t. Correct? Okay. Provided to an ideal transformer. Ideal transformer now what? Input power will be equal to output power, having 1000 turns in the primary coil and 100 turns in the secondary coil as shown in the figure. To load circuit has a resistance of 4 ohm. The capacitance capacitive reactance வந்து 2 ohm, inductive reactance வந்து 6 ohm. Okay va? So இப்போ வந்து you should find the output voltage. அதுக்காக we can just use one, I mean we have the relation Vs by Vp which is equal to Ns by Np. அப்படினா we can go for Vs na என்ன? Ns by Np into Vp. All the values are given. Can you find it? Just substitute the values and find it. All the equations, everything is here. Now you can just go for substituting and you can find it. $255. So of course, let us just increase our criteria, 300 likes in the session. Before we are finishing the lecture, we should get 300 likes. Let's see. Okay. So, and as I mentioned, all the time, whenever you are thinking like, okay, after the CBSE, what? If you are preparing for Neet, stay. We are going to give, as I mentioned, quality lectures we will give. Trust me, it's going to be a very, it will create a impact in your Neet preparation. Okay. So, we got it. We input. Okay, and we input order not getting, okay, I can just read from here. Okay, so இப்போ we know Ns na secondary coil 100 turns irukku, and Np na enna guys? Np na enna? 1000. Okay, and Vp na primary input whatever we are giving. So அப்படினா we can say 200 sine 100 pi t. You can substitute. Okay va? So always I'll tell you the thing, Dhoni. The thing is like whenever we are doing something, even if you are studying also, don't think like I will study 14 chapters together. Keep a very small achieving things, which means I will study first chapter today. Okay, today in by 1 p.m. or 2 p.m. I will study first chapter. Okay, so once you did it, you will feel like more confident. Ana let us say I'm just going for today I will study 14 chapters. In this day itself I will study 14 chapters. Enna agumna, of course, in the 14 chapter when you start the first chapter, when you go to the second chapter itself, you will be get bored. Okay, ஏனா இதுல difficult ஆன questions இருக்கும், concept understanding will be difficult. So அதனால தான் சொல்றேன், whenever you are keeping a very big target, you will get bored immediately. Even if you are studying, even if in terms of like whatever it may be, that is the fact. Always keep small, achievable, okay, which you feel like easy. And the madri, if you are setting your targets na, of course you won't get bored. Okay, so if I'm just in the beginning I'm telling you, எனக்கு 100 like வேணும், 500 like வேணும். So what you people will do? Of course, in the beginning, konjam students mattunda irukke. So it is very difficult to get it. So adanale we will be, achievable thing I have, achievable target I have given to you. So that was happened. Purinjada logic. Eppovume whenever you are studying, even in your life, whatever be the steps you are choosing, always keep this thing step by step. Don't just try to go like this. Step by step, if you are going, it is going to be fine. Okay? Okay, va? Okay, va? So we will be getting here, I'm just going for the substitution only. 1000 into Vp value 200 sin 100 pi t. Okay, va? So next one, the current flowing through the load circuit. Current flowing through the circuit na, idu vandu LCR circuit. Adinala current vandu Vrms divided by Z. Okay? So ipo vandu you should find Z. Z na enna? Root of R square plus XL minus XZ the whole square. So ipo vandu you can go for XL minus XZ. Okay, you have all the values there. Can you find XL minus XC for me? That is again a sample question paper that is made by myself. So you can just work it out. Keep a 3 hours time and finish it. Okay. So adu vandu confidence build agradhukku tha. Okay. Confidence in, if you have the confidence na, few things we can do it with that confidence. And the confidence build pandradhukku, you should do this kind of things. Okay. So inneke you should solve a sample paper and you should tell me, ma'am, did it. Done. Okay. So tell me what is XL minus XC? What is XL? It is directly given. Okay. What is XL? 6 and C for this XC is 2. So we will be getting 4 ohm. Ipo vandu you can find this one. So R na enna 4. So 4 square plus 4 square na, you will be getting root 32. Okay. So ipo vandu you got Z. Okay. Ipo vandu you need to know Vrms. Vrms na enna? Vrms na peak voltage divided by root 2. Peak voltage enna guys? 200 divided by root 2. Purinjadada? Purinjada? Okay? Okay? So ipo vandu you got Vrms, you got the Z value, you can substitute. So ipo vandu, yeah. So ipo vandu we should know the power supply to the load circuit by the transformer. Power supply. How we will be finding the power? Power order equation enna? True power order equation enna? IRMS into VRMS into cos phi. So cos phi na enna? Cos phi na enna? R by Z. So you can substitute. Done? Done or not? Okay. So I'll just give you the steps again. The output voltage kaga, it is given, it is an ideal transformer. Adanala VSIS which is equal to, VS by IS, Vs by Vp which is equal to Ns by Npn, and the values are given directly in the question. So you can find it from there. And next one, the current. Current kaga we should go for the equation. Yena idu vandu LCR circuit da. Adanala Vrms divided by Z. Okay. So first one the ninga Z, you should find Z. Adikaga values ellam directa it is given. Okay. Then you should find Vrms. Vrms kaga you can, you know the peak value. You know the peak value 200 divided by root 2. Okay. Substituting that will be giving you IRMS. Next one, you should know the power. Power kandupidikkiradhukaga, the true power kandupidikkiradhukaga, we know the equation Vrms into IRMS into cos phi. So Vrms we already know 200 divided by root 2. IRMS you already find it from here. Then cos phi na R by Z. R na 4, Z na 4. Okay. So sorry, R na 4, Z na root 32. Okay. Root 32. So you will be substituting, you will be getting the cos phi as well. Power you will get. Next one, the state the working principle of transformer and explain how it is a key component in the transfer of electrical power for longer distance. Ipo vandu neenga paathena, we know what is the principle. Principle enna guys? Principle enna? Yesterday we have studied transformer oda principle enna? Transformer oda principle enna? Adu vandu mutual induction, right? In the primary coil we will give the current. Correcta? Correcta? In the primary coil we will be giving the we will give the input. Okay, so இப்போ வந்து இதுல அந்த primary coilல current will flow. அந்த current flow நால அங்க ஒரு magnetic field இருக்கும். அந்த magnetic field use பண்ணி there will be a flux change will happen in the secondary coil. And the flux change nala, we know if there is a flux change that will leads to an induced EMF, and the induced EMF produce achu, generate achu. So adha vanda nama secondary coil la we will be getting the output voltage vanda. Output voltage vanda, it is due to the primary, the current which is passing through the primary coil. Adha vanda mutual induction. Okay, va. Next vanda, how it is helping us for the transfer of current from, we know that we will be in the power station, we will be producing the current. Okay, so in the current, in the current, if it is coming with the same way, there will be a lots of power loss, there will be a lot of what to say, heat loss will be there, power loss will be there. Okay, and avlo distance ippadu varumbodhu it will experience a lot of heat loss. Avlo current, I mean, if there is a heavy flow of current na ange power loss irukkum. Adinala, once we made the current in the power station, then we will use a step-up transformer to increase the voltage. Voltage increase agumbodhu, we will be getting using a step-up transformer, we can reduce the voltage. Adilirunda the current will come. So in the current nala, I mean, due to the long, I mean, it has to travel a longer distance, and the longer distance travel pandradunala, heat loss we can reduce. Once it is reaches the substation or near to near to the substation only. So on the substation la varumbodhu again we can step down and we will be getting the current. Purinjudha everybody? So that is what we need to study. That is how the step up and step down transformer is helping us to reduce the heat loss. Also it will help you to reduce the amount, or the amount of required for making the wire and everything, so that will also be in a part of it. So this will be helpful, and the working principle kappuram you can write idu vandu, it will help to reduce the power loss due to the longer, it has to travel a longer distance, and the time in the step up and step down transformer use panni we can reduce the power loss. Okay, and we have one more question. Draw the reflected wave front and plane wavefront incident on a plane reflecting surface and prove laws of reflection. So adukkaga very simple, idha vandu namma wavefront. Okay, incident ana wavefront. Ana after reflection it will be like this. Okay, it will be like this. Now you need to know, you need to do one thing only. You should prove this triangle and this triangle and this triangle. Okay, in the two triangles one the congruent, which means two sides as well as one angle are same. So appadina I can say that in the angle one the 90 degree, in the angle also coming as 90 degree, and both this triangle is having two same surface, same side AC AZ, angle one the same, and idhula one the in the velocity one the same mediathilana adanaala we can say that velocity is same. So ipo vanda in the incident plane wave vanda it will fall on the surface. So and the time la it will reflect back, and the time la in the side vanda it will come and it will hit. So the distance traveled, which means in the distance as well as this distance is going to be same. Yena distance vanda velocity into time. Okay, we are calculating for the same time. So in the same time la travel pandra distance vanda same a irukum. So adanala I can say that I'm just writing few names A, C, B, D. Okay, so this is AD. Appadina I can say that angle ACD which is equal to angle ABD. Okay, next one we can say AC which is equal to BD. Now one we have proved, we have done the proof in the two sides and one angle one the same irukku. Adinala in the two triangles one the congruent. Adinala equal sides ku opposite irukra angles kuda equal a irukum. Adinala we can say in the incident angle. Okay, incident angle one the it will be equal to the reflected angle. So in the angle one the equal to this angle. புரிஞ்சுதா? So this is what the proof we need for the question which we have already done. So CBSE sample question paper வந்து complete we have solved. Okay, so in the you have listened the class, that doesn't mean like you will be getting or you can do better. So focus on the questions and everything whatever we have done, do it again. In the sample question paper வந்து CBSE site ல available இருக்கு. Okay, CBSE ஓட site ல if you are just checking on physics 12 class 12 sample paper na you will be get it. So spend some time, just try it again. If you can do all the questions, fine, you have studied something. Okay, so adanala tha you could do the question again. Listen the class, that doesn't mean like it will give you some output. Okay va? So adanala tha solre everybody should do this question paper again. And already one more video is going on. Adu vandu 10 next 10 hours la adu play agum. So on the time la and the PDF will be available for you, so you can download and you can just do the questions and you can practice. Okay, and adu vandu time, you should keep the timer, illana exam ku vandu time management vandu konjam difficult ah irukum. So adanal start your preparation from now onwards. And as I mentioned, idu vandu CBSE ku mattum illa, NEET preparation kaagum we are going to do something more. So adanal vandu channel subscribe panniko, like panniko, share panniko, and Telegram channel la join panniko. Ipo you need 38 years question paper, NEET oda question paper oda if you want it chapter wise, adu vandu nama description box la link irukku, you can just visit it and you will be getting the if you want, you can, if you feel like I need this, you can purchase it, you can start your preparation. Okay va? So in the sample question paper mattunda. Okay, don't think like if I'm studying this question paper I will get the full marks. Don't think like that. This is a practice. Okay va? Everybody is okay? Okay, so now tomorrow we will be doing the previous year questions. Major we are going to focus on numericals. Adanala miss pannama. Okay, miss pannama you should attend. So see you guys. Bye all.